hybrid session, if I can call it like that, because we will start with two keynotes on Copernicus contributing missions. It's a bit the bridge between what we discussed yesterday about what Copernicus is offering, and then what we will discuss the rest of the day, where we really concentrate on data dissemination. So the third of the keynotes today is really about data dissemination. But we start this morning with Peggy Fisher. She's working here in ESRIN in the Earth Observation Directorate, and she is the mission manager for ESA third-party missions. And obviously that also means that she's our contact person and our favorite contact for Copernicus contributing missions, which we call CCM all the time. So every time you see us mentioning CCM, it's Copernicus contributing missions. And she will explain you all about this topic. Please, Peggy.
Thank you, Tim, for this introduction. And good morning to all of you. First of all, I would like to thank the organizers of this workshop, my colleagues, Giuseppe, Federica, and Mark, for the invitation to speak about ESA third-party missions and Copernicus contributing missions this morning. And now I would need my presentations to start. Okay. So let me give you an introduction about these two programmatic elements, ESA third-party missions and Copernicus contributing missions. ESA, the Earth Observation Directorate, is purchasing complementary Earth observation data and also associated provisioning services, of course for its own purposes, but also for other institutions. And that's why we have two programmatic elements, the ESA third-party missions and the Copernicus contributing missions. The ESA third-party missions are here to foster science and R&D needs in Europe. We are sponsoring complementary data to institutions, research organizations, and also to commercial companies for incubation activities. Whilst in the Copernicus contributing missions, the aim here is to complement the Copernicus program with high-quality complementary commercial data primarily in complement to the Sentinel observations. And here we are really providing operationally on a daily basis data from so-called established data providers, but also the emerging European data providers to the different Copernicus services. In both cases, ESA is acting as an anchor customer for Earth observation data. So the ESA third-party missions are the central component of the ESA EarthNet program. We have been sponsoring a lot of research projects over the last years. Just to give you a number, 18,000 projects were sponsored by ESA with TPM data since 2008. And TPM is considered a key mechanism for Earth observation capacity building, meaning that this allows to engage with research and academic community, and it lowers the barrier to entry for new users, including early adopters to Earth observation. If you want to know more about the third-party missions, of course, you have the link here to the website, and you have the full portfolio of the TPMs available there. I would like to show you this infographic also to illustrate that the ESA third-party missions support a broad range of Earth observation applications development and Earth science domains. You see here we are going from hydrology to coastal zone to atmosphere, hazard, land environment, oceanography. All is possible thanks to the complementary use of TPM data together with Sentinel observations and the ESA science missions. ESA has invested a lot over the last years to further evolve the TPM data portfolio. You see the timeline here. We have worked over the last years, primarily in onboarding what we call the emerging European scale-ups, startups in Europe, in particular in the emerging data domains, so ranging from atmospheric composition data to hyperspectral data, thermal infrared, of course also multispectral and SAR data. You see there has been a large evolution over the last few years, and in 25 we have also started to engage with, for instance, Aurora Tech and Constellar in order to obtain some thermal infrared data for science and research. I think it's important to highlight the license around the third-party missions. I think this is important to know here. So who is eligible to obtain data from ESA around the third-party missions? Foremost, of course, the research and the development entities in all ESA member states, ESA participating in cooperating states. And here I'm referring to all universities, research institutions, and also to statistics offices in Europe that have the right, of course, to submit a project proposal to us. We are also able to serve, of course, always allowing the budget we have available, R&D and innovation teams of commercial European companies, but only for non-commercial and non-innovational activities. And we also are able to foster and sponsor data to ESA incubators and business incubation centers for civil Earth observation research applications. So in order to obtain commercial data, a project proposal is necessary, and we also encourage each researcher or company that is using TPM data to provide us with a detailed final report, which then also allows to promote the work and to publicize all these success stories that are coming out of the use of TPM data together with Sentinel and ESA science missions. There is a process to be followed to obtain TPM data, so this project proposal mechanism. I will not go into the details, but please have a look at our website and follow the different steps. There is a form to be filled, and you will be able to submit your request, which then is evaluated by ESA, of course, in terms of scientific objectives and usefulness, level of innovation, but also is evaluated by the various data providers if they are keen or not to sponsor research that is being proposed. Now in the next 2 slides, I would like to highlight a few examples that we have extracted out of our large database, of course, of TPM success stories, which are more related to, let's say, the use of high-resolution commercial data for statistical purposes. So here there is an illustration of one project, in this case FAO, submitted a request in 24 for gaining access to very high-resolution SAR data for a project which was called EOStat for RISE. And the use of Cosmos SkyMed data in this case allowed them to, combined with other data sources, allowed them to generate high-resolution accurate RISE area maps and also detailed area statistics. And yeah, they promoted this work, and we were very happy to of course, allow them to work on this important research. In another 2 cases, we sponsored very high-resolution optical data for the use of, let's say, commercial data for statistical purposes. In one case, this was an ESA internal project in which ESA was looking into the adaptation and improvement of EU practices in agriculture statistics using satellite data and machine learning. In this specific case, we sponsored some Pleiad Neo and PlanetScope data for this research. And in the second case, in a collaboration between the University in Brussels and the Leibniz Institute of Ecological, Urban and Regional Development in Germany, we provided some PlanetScope data, which they used in combination with LiDAR-based LiDAR data, as well as high-resolution airborne imagery to generate very high-resolution information in order to assess selected ecosystem services across multiple urban sites. Now, are moving from the ESA third-party missions to the Copernicus contributing missions. The Copernicus contributing missions are now an integral part of Copernicus. We are serving all the 6 Copernicus services. I would say with a growing demand of complementary data, primarily commercial data, but also there is a possibility to, of course, provide national data, institutional data to Copernicus, but the focus for the moment is commercial complement. Here you see the different Copernicus services, and we are primarily providing data to all the Copernicus security services, to the emergency management service, to the land monitoring service, EEA, the marine monitoring service, the atmosphere, and also climate change to some extent. Over the last years, we have also opened up to other user groups, of course, always in close collaboration with DG DEFIS, including projects linked to Horizon Europe. They are also using growingly, let's say, the data from these emerging data providers in the new data domains, and we are also serving some other end users of the European Commission outside Copernicus services. What is important to highlight here is that this is, again, a fully operational service 24/7, rapid tasking of satellite data, and that the complementary use of commercial data is largely following also a European strategic autonomy approach, meaning that primarily we are sourcing data from European providers. Of course, this is not always possible, in particular when the demand is very high for specific data sources, and then there is a complement also, an important complement coming from additional satellite contributions from other companies that are supporting Copernicus. In all of this, I have to emphasize that we're talking about commercial data provisioning to Copernicus. It's extremely important that the data quality, of course, is fit for purpose. So here, there is a rigid process in place where expert teams, ESA and expert teams in Europe are looking at the different commercial data sets that are being provided as part of a framework which is called Copernicus performance clusters. And here experts are looking at the same time at the Sentinel data as well as the commercial data. So for example, the expert teams that are looking at Sentinel-2 are also assessing data from the optical very high resolution data providers. Yes. A few more slides on contributing missions, just to show you the portfolio. It's a large portfolio now. We are covering all types of data domains, from multispectral SOAR to the various emerging data domains. There is a lot happening in what we call Category 1, where we have onboarded 15 companies now to gradually enable Copernicus to use additional data. And we are working a lot with the different Copernicus services to stimulate data demonstrations and onboard this data. Just to show you an illustration of the data that is emerging in this environment of Category 1. You see some examples here from companies like Aurora Tech or Constellar or Kuva Space, Geosat, Absolute Sensing, but these are just a few examples. There are again 15 companies in this Category 1. Important to highlight is that, of course, these emerging data domains, hyperspectral in particular, also thermal, are unlocking additional opportunities for science, but also for operational services. Hyperspectral data is able to look into many more soil characteristics than any other data, or thermal infrared is able to detect urban heat waves, also looking at irrigation monitoring and many more applications. Very quickly, data access to CCM data. There are two main portals how users can obtain data. One is on-demand CCM data, and this is going through the rapid response desk, where we have a 24/7 service in place, which is very rapidly providing data, in particular to the emergency management service, the security services, in order to map or provide complementary data if there is a disaster event happening, and making sure that the value adding is going out as soon as possible. And I invite you to, of course, look at the QR codes and access the sites. And then there is a wealth of data in the Copernicus data space ecosystem where my colleague Jolien will go into much more detail. There you find all the what we call systematic CCM data sets, Copernicus STEM, but also the very high resolution coverages. And here I would like to draw your attention to this, which maybe is not known to many. There are pan-European coverage out there, 2-meter resolution across all European countries, time series starting from, you see, 2012. The latest edition has just been published, 24. And each coverage is over 6 million square kilometers of data, so this is enormous and can be reused if you are eligible to it. And I would like to highlight in the next slide what are the eligibility criteria to access this data. So who can access CCM data in both mechanisms, the Rapid Response Desk and the Copernicus data space ecosystem. Of course, the Copernicus services, they have all the rights not only to view the data download, but they can also task satellites, so they can really tailor acquisitions to their purposes. Some union research projects under EU framework programs can do the same, less flexibility for tasking. And then I would like to illustrate that there are the national public authorities, which I believe is also including all the statistics offices in Europe. They are allowed to not only view the data, but they can download all these coverages. And that is my last slide, Tim. Just to make sure that it's clear that the user categories are well explained. So again, the national public authorities, this is a slide just to go into a more depth of who is eligible here. Public authorities, so all national, regional, local administrations, civil protection services, statistics offices in Europe, public advisory boards, but also public service providers related to environment. So any entities performing public administrative functions, organizations delivering environmental services under national law, and many more. You see also all research and academia institutions in Europe. So all universities can access this data, as well as, of course, contractors that are working with these entities. So again, I invite you to look at, in particular, the Copernicus data space ecosystem and find out what is there. Thank you very much for your attention.
Thanks a lot, Peggy. I will not ask for questions. There is a lot of information that Peggy has transferred to you, and I think the important thing is national institutions have access to many of this CCM data. So don't hesitate to reach out to Peggy after this session or later on via email or other channels. Next, I have Annika Hoek, who is also going to talk about contributing missions. She's from the European Space Imaging, and she is responsible for the interaction with European organizations and national government agencies. She has a lot of experience in Earth observations already, and today she's here not only to represent European Space Imaging, but also the European Association for Remote Sensing Companies. We call it ERSC, but I don't know if we're allowed to do that. Okay, perfect. So Annika, the floor is yours.
Okay. Good morning, everyone. Thank you so much for having me here. Thank you so much for inviting me. Again, it's my special pleasure really to present not only today the company I'm working for, European Space Imaging, but also ERSC, the European Association of Remote Sensing Companies. Maybe to give you a little overview in case you're not familiar with ERSC, it's an association based in Brussels, actually representing over 140 Earth observation companies, and they're situated in 25 European countries. Maybe also to say 2 words about the Earth observation downstream sector. I mean, we have actually really seen a massive growth over the last couple of years, which is really, really fantastic. Again, this is a positive tendency, which is, has been also continued in the last 2 years. And maybe one thing to mention, I mean, the growth of the sector is due mainly to the defense market and as well also the development of national constellations. Unfortunately, or let's say there's a tendency that only large companies benefiting from this tendency, and unfortunately SMEs and startups are less kind of beneficial from this latest developments. Nevertheless, there's a very positive trend, and I really hope obviously we will continue in this direction, also thanks to anchor customers such as ESA and the European Commission. Also, to be very clear, what does actually the Earth observation value-adding chain really entail? We're really starting from the data provisioning. So the company I'm working for, European Space Imaging, is a data provider. So we're really located on the very left-hand side of the diagram. But of course, we have all the value-adding companies, and then also the provisioning really of the final products and information to the end customers. And again, so we have sometimes also end customers such as the institution itself. So we will provide directly the data, as for example through Copernicus contributing mission or the third-party mission, as we heard before, or sometimes really industry in collaboration really provides special services, which I will show you a few examples later on, to end users, sometimes also, for example, the national governments or statistical offices. Here in a nutshell, we already heard a lot of what is actually the commercial sector providing to Copernicus program from Peggy before, but here just in a nutshell, it's really bringing together the past experience, or really the archive access. I mean, European Space Imaging, for example, is not one of the newcomers, it's not a startup, it's actually one of the old-timers. We are providing an archive of 25 years of EHR data over Europe, which is really, really time-critical for many applications, for example, for the monitoring of deforestation or other application areas. Then, of course, we have the new acquisitions, especially for time-critical applications, such as emergency applications. And also especially to provide this data then in a very timely manner to the end customers. And we already heard there's obviously the VHR component, which the commercial sector is provided, and we are really happy that there's such a nice fit together with the public sector. And why is all this contribution so relevant? As mentioned before, it's really key to provide actually insights over time, to generate foresights that clearly can help decision makers to take their decisions. So, and also for this, obviously, sustainability is key here, to really be consistent in terms of data, which is brought into the programs, and to really have a reliable time series. Here, just to give you an idea with a few very precise examples, for example, if you look into spatial and temporal resolution, what can really the commercial sector bring in comparison to the Sentinel fleet? For example, if you look at the spatial resolution, we talk about 30 centimeter products here at most at the moment, but of course there are also lately other developments to actually push these limits even further. And in comparison to, for example, a freely available 10-meter product provided by ESA. When it comes to the temporal resolution, it's quite remarkable. For example, again, I can speak for my own company, for UC, we can provide up to 6 acquisitions over an area of interest in one day. While, for example, the Sentinels overpass the same area of interest every 5 to 6 days. So again, depends very much on the end user needs. And we already heard, obviously, ESA is enlarging their portfolio, which is really great, supporting also newcomers such as Constella or Cuba Space. This is really, really exciting also to really push the limits when it comes to the spectral range. We already heard about it, just to remind you where basically the contributing missions are situated. We are being part of the space component, and again, we are basically providing data to all the Copernicus services, but again, the power users are obviously the emergency and security services, as well as the land monitoring and marine service. I will just provide you a few examples so you can really see the value added. We would start off with the emergency service. It's one of the oldest operational services, actually, being already implemented since 2012, and it addresses natural and man-made disasters. And it goes really through all the different phases. So we are really talking about early warning system, risk and recovery mapping, as well as rapid mapping. Again, the access is free to different users, but the service can only be activated by authorized users. And just to go a little bit more in detail into the rapid mapping component, this is a really interesting service. It's a 24/7 service. It's really providing time-critical provisioning, time-critical Earth observation products and information to the end users. It's been activated around 70 times per year with a positive growth rate. And here we have an example. There was a forest fire. It occurred in 2019 in central Portugal, and there the National Authority for Civil Protection actually activated the Copernicus service 2 days after the disaster occurred. And what is really remarkable here, you see that after the service has been activated, the map or the satellite was tasked, the image was delivered, and the map generated within a single day. I mean, this is really, really key here, and you really see the value added, which then the public service unfortunately cannot provide such a service. Another really prominent power users of, let's say, the Copernicus contributing mission is the security service. There are 3 elements to it. One is the border surveillance, the support to the EU external action, and the maritime surveillance. Again, this is also a 24/7 time-critical service and may only be accessed by authorized users, and unfortunately, then these products, due to confidentiality, are not accessible to all user categories. Here's one example which was actually provided by Frontex as well as SATCEN, and it's regarding the monitoring of migration activities along the EU external borders between Greece and Turkey. Another example comes from actually the maritime service implemented by EMSA, and this is a really manifold service, fantastic, from fishery control up to environmental pollution monitoring. For example, we have here one example coming from the Virginia accident, and you can see here the oil spill was clearly identified also in optical VHR data. Usually also here brings really a service together, bringing also different sensors together. Usually oil spill is detected by SAR data, but again, depending, bringing different sources together can really generate the most viable products for the end users. Another service is actually a near real-time operation service, again provided by EMSA. It's vessel detection and classification, and it brings together again SAR and optical VHR data together with positioning reporting. And this service is used for fishery control, again up to environmental monitoring. And also here, the time for image processing is quite remarkable. So really, again, the time criticality is really at heart of the service. Then another product we already heard about, so I'm sorry for being repetitive, but it's really a fantastic product, and we are being really, really proud also as a company that we have contributed over the years always to the VHR coverage. Again, it's every 3 years basically there's a new update to the coverage. Companies only acquiring data during the growing season, and this fantastic VHR product is based as a validation layer for the Copernicus land monitoring service, as well as to different land use and land cover products and initiatives. The main user is the European Environmental Agency, but again, the product is available also to the national authorities. Here, maybe just one quick example. You see, UC was here in a consortium together with Airbus, and we made a joint effort to really produce the, well, let's say almost 100% coverage. In 2021, we are currently again together in a consortium with Airbus producing the latest one, the VHR 2027, which is really fantastic. Maybe just a little spoiler for you, in case you're planning to go on holidays to Martinique, you might want to reconsider, because apparently it's cloudy there 99% of the year. So again, we already have seen this slide. Just as a reminder, there's a lot of fantastic data out there, and we really like to remind the end users, use this wealth of data, because again, it's really there for you. To wrap it up, okay, 1 minute. Again, there's obviously a lot of data needs out there, which are currently not covered by the Copernicus services. There's a lot of, again, this is not a full list, but again, a lot of emphasis from industry to already push the limits. Just going very quickly through here. There's, for example, initiatives to really create baseline mapping for deforestation monitoring, which is fantastic, especially now the EU forest monitoring law unfortunately fell through. Then we have, for example, reporting for EODR diligence. Then again, it's really time critical to provide over time information on deforestation around plantation. Here we have been actually in a collaboration with, again, a value-adding company called Airborg, and they're using VHR information and data together with AI to really produce tree-level information over time. The almost last one is also then related to soil organic carbon monitoring is also one of the hot topics which is currently not included. For example, the SWIR spectral range is not included in the Copernicus services. Also, this could be a really interesting product on European scale in future. And also another very last one initiative done by UC. We proactively, for example, acquire data every year in HD over all European metropolitan areas. So we really try to create really an off-the-shelf product to fill gaps between national area collection and non-existing open data. So we're really trying to be proactive there and work together with the public service. And with this, I thank you.
Thank you so much, Annika. Well, you've seen the contact details on the screen. Again, I will not go for questions, just to try to not delay the schedule from the first session already, schedule of the day. So you heard about contributing missions, about third-party missions. You've seen how the industry is a very important player behind this. We always say ESA is doing this, or the Commission is doing that, or whatever institution is doing that, but there are always contracts behind it. There is a whole industry behind it. It's important to keep that in mind. Now, you've had a very good overview of what we offer of third-party data. Yesterday, you had a very good overview of what we offer, what Copernicus is offering of Sentinel data and information and services information. But where to get it? There is only one man we can ask to give the perfect introduction to that, and that is my next speaker, Jolyon Martin, who is also from ESRIN here, from ESA, from the Copernicus Data Management Division, and he is the head of the Copernicus Ground Segment Systems section, and he will tell you all about how CDSE, the Copernicus Data System, is working. And if you remember from my very first presentation yesterday, CDSE is one of your entry points to get to data, just like Wikio is also one of the points, but CDSE is the one that is really fit for usage in statistics, and the Eurostat colleagues will confirm this. Jolyon, the floor is all yours.
Thank you. So I'd like to give a really brief introduction to the Copernicus data space ecosystem. So where you can get the Sentinels plus much more all at your fingertips. If I have to reduce it to one phrase, we would say that the CDSE is a resilient, high-quality operational service for Copernicus data analytics. It's built on the European industrial expertise. There are various facets of the CDSE, and I'll go through them all in this presentation. The ground base is that the CDSE is the authoritative source for the full and up-to-date access to the largest Sentinels holdings. So the complete archive of all of the Sentinel missions 1, 2, 3, 5P from the beginning of the mission, all available online. As well as the contributing missions data, plus more, all digitally traced for a permanent record of authenticity. This is one of the nice features of the CDSE. It provides a digital fingerprint of all of the data to allow to verify its authenticity. The CDSC provides standard interfaces, advanced data analytics, and cloud services to process that data with the large volumes of data that we have. Now, downloading the data to remote workstations is increasingly painful, and the CDSC proposes a number of interfaces to allow you to process the data in situ on the cloud where the data is sitting. It provides open and free capacity for all users with self-registration, so any user can access the data. When the fair share of the quota is exceeded, there are possibilities for commercial extensions to further access and process the data. It provides many onboarding possibilities and federation possibilities. I'll go into those later. And again, it operates a continuous evolution and innovation cycle for fostering the development of a European ecosystem built on Copernicus data. So the data holdings, the full archive of the Sentinels from the beginning of the operations are available for immediate access, as I've said. So already there are over 84 petabytes of data from the Sentinel missions there. There are also all of the CCM data, the systematic coverages of the CCM. And it's complemented with other additional data from the Copernicus services, additional data sets including Landsat Collection 2, MODIS, and many others. One of the data sets, or a couple of the data sets, would be nice to highlight. The CDSC also provides mosaics, so pre-processed data, monthly mosaics of the Sentinel-1 data, and cloud-free quarterly mosaics from Sentinel-2. And these are probably a very good source for statistics information, allowing a rapid processing of the full-time series. Other data include the Copernicus Land Service data portfolio. At the moment, there are 544 data sets already onboarded and more on the way. To access these data, the data are made available following the FAIR principles, so findable, accessible, interoperable, reusable. The CDSC is deploying the latest standards to allow to access these data with cloud-optimized interfaces. So STAC, which is the Spatial Temporal Asset Catalog, very much the lingua franca of the geospatial data at the moment. OpenEO, which is a streamlined service which allows processing the data in situ, and also OGC services which ensure interoperability and availability of the data in many tools. These accesses are underpinned by the S3 APIs, which allow you to stream the data, immediate access to the data in a scalable and secure fashion. So this is the de facto modern interface for object storage in the cloud. So the CDC is providing high performance and resilience, so immediate access to all of the data, as well as federated data sets. Cloud processing, so avoiding the need to download the data. The volumes are such that doing serious analysis it is not any more possible to download to your local facility and process all the data. It's providing a resilient service through multi-cloud offer, so it's in two European clouds, one in Poland, one in Frankfurt. And it has, the core capabilities to create an open ecosystem based on API access, code repositories, cloud processing, as well as third-party data and services. CDSC is the first point for the open and free access, so any user can self-register. It has an ample quota for the public download and processing with a capability to offer commercial services when needed, when going beyond the fair share of the resources available. There are Jupyter Lab and streamlined APIs for processing the data without the need of download, and there is no quota restriction on the amount of data you can process through the Jupyter Lab or the streamlined APIs when operating on the cloud. Okay, I've already said extended capacities available at commercial conditions. So really the data are there and ready at your fingertips for rapid analysis and prototyping through the many tools and interfaces offered through the CDSE. As well as hosting the Copernicus Sentinel data, the land data, the CDSE is open to onboarding and a federation of other data sets. We have been supporting many organizations to bring their data to the CDSE and allow it to be processed alongside the Sentinel data. It's offering advanced interfaces such as the OpenEO tool suite, web editors, and APIs to process the data online. And it has already brought into the global component, pan-European component of the land monitoring service, and providing a seamless access through the same interfaces where you can find the Sentinel data. We are starting in the CDSE to also onboard new space category 1 Copernicus contributing missions, so enabling the close proximity of the access to the new space data and the Sentinel data for downstream statistics and EO services. So, as I said at the beginning, CDSE manages a continuous innovation. There are many improvements continually deployed on the CDSE. One of the major offerings on the CDSE is the OpenEO processing suite. So this comprises a dedicated web editor, a Jupyter Lab with plenty of example notebooks to initiate the processing online. There are machine learning examples, and also just recently added notebooks in R the notebooks are available in Python, but also now in R as well. The OpenEO interface is integrated into the Copernicus browser, so the main interface where you can visualize prototype data. This means that the process graphs, which are describing additional processing on the data, are interoperable through the notebooks, through the browser, and elsewhere. There is the OpenEO Algorithm Plaza, which allows you to share user-defined processing, so your own processing can be processing algorithms can be offered back to the community and shared there. There are many performance enhancements in the CDSE. It's now being used in many continental and global scale projects. Some examples up there to really process continental and global scale full-time series. There are a series of webinars and many resources to help you get started. So over 67 million requests were processed in OpenEO in 2025. Many other features, so as I say, continuous evolution, there are new data and new features regularly onboarded. So recently we've launched the Sentinel-1D, and the commission is now complete. The data are now flowing fully operational into the CDSE. There's the Sentinel-2A extended campaign, which is going on, which provides an even better coverage of the Sentinel-2 tape, Sentinel-2 over Europe and Africa. There are some innovative APIs as well to allow targeted access to the burst data inside the Sentinel-1 data. So some very innovative APIs to be explored and to be exploited on the CDSE. The public roadmap is made available, and you can check out what's happening on there. So as I said, there's also the real goal of the CDSE is to foster the development of a European ecosystem on top of the EO data and services made available from Copernicus. The CDSE has supported, for example, a number of hackathons, including Eurostat European Big Data Hackathon, and is happy to support other hackathons as well, providing workspaces, AI and ML-ready workspaces for such events. So the CDSE user uptake is very impressive. So the CDSE already has over 600,000 users registered. The Copernicus browser is available for anonymous use as well as registered users, and we have in the last 30 days over 700,000 visitors to the browser to look at the data, to play with the data, to analyze the data. And it has, in the last 30 days, over 89,000 active users, individual active users who are logging on and using the services. Many other statistics that I won't bore you with, but plenty of resources available through videos on the YouTube, and there are information routinely disseminated through many newsletters as well as LinkedIn as well. So I think later today there will be an opportunity to interact with the CDSE consortium. William Ray, I haven't spotted at the back. Okay, our colleagues at the back, and I really invite you to go and to see what's available through the CDSE and ask how we can help you. And that's my presentation. Thank you very much.
Thanks a lot, Julian, and thanks to all speakers to try to squeeze your presentation so we end in time. We do have time for one, maybe two questions. Are there questions in the audience for Julian and even for the previous speakers? No, you want coffee. Okay, in that case, don't hesitate to contact these people if you want to ask more. I would like to ask for a round of applause, and then Federica will tell you how the rest of the day will go.
Thanks very much, team. Thanks to all the speakers for the excellent introduction of the day. We really hope that this session, but also the sessions we had in the last 2 days, gave you some food for thought and some inputs for the work that lies ahead today, because now it's your time to get down to work. So we have a full day of workshops in front of us. So roll up your sleeves, and I'd like to maybe give a very short introduction of the different ones. So now we are about to break for, let's say, 5 minutes for a coffee to go, just to split in the different sessions in the different rooms. So in this room, in the big hall, we are going to have a workshop on accessibility, data infrastructures, and interoperability. So the panel we just saw, it was the perfect introduction for this workshop. And the second one is going to take place in the Magellan on trust of EO data and uncertainty. So this workshop is going to explore how the transparency and uncertainty quantification that can be informed, of course, by the statistics standards can help increase confidence and trust in EO-derived information. Then we have a third one that is more thematic on agri-food systems. So this will delve into how to discuss the best standards for EO for official quality agriculture statistics. Then we are going to have a coffee break and then time to split in other rooms for different sessions on the first one on reference data. So we saw yesterday in the first day we saw how important it is for all of us the importance of reference data and in situ data. So this one will be discussing precisely this. Then a workshop on capacity building. This was also another key hot topic discussed in this conference. And then the third one in James Cook is also more thematic on forest statistics. Then we are going to have the lunch break, always at 1:30 again. And then we are going to have our last two workshops of the day. So the first one is again on in situ data. So if you missed the first one, so maybe you can have another opportunity to join this discussion. And finally, the second one in parallel is going to discuss about standardization of Earth observation into the statistical system. So I think it's going to be really interesting. If you are not, of course, you cannot join all of them if you are interested in more of the parallel ones, but you will have the opportunity to listen to what has been discussed in all the different workshops, because we are going to have a workshop wrap-up session at 4:15 p.m. So we asked all the workshop organizers to provide a very short summary, 3-4 minutes for each workshop, so that all of us can listen to what has been discussed. So with that, I close this very short introduction, and I wish you a productive and a nice day ahead of the workshop. Thank you.
Thanks a lot.
You're welcome.
I guess you're disappearing now.
I am going to disappear after a quick coffee. I think I will take coffee now. I am sure we'll see each other soon online.
Okay. Yeah, I'm gonna first start with the presentations. I saw these. Hello, everyone. So let's start with workshop 4. Is everyone here that wants to join? Are there still people in the cafe area, maybe? You got them here? Yeah, thank you, Hannes. Okay, so this is a workshop where we're going to explore accessibility and data infrastructure interoperability for the purpose of getting communities, statistical community to work with Earth observation data, but I think also vice versa, that Earth observation community is able to work closely with the statistical community. And in the workshop today, we're gonna answer this question primarily. So how might we make Earth observation data infrastructure more accessible and interoperable so that statistical offices can adopt it as a routine part of their production? And we're gonna start the session with 2 presentations, kind of setting the scene for inspiration of the discussions and workshop exercise that we're gonna have later. So we're gonna have 2 back-to-back presentations, as I said, and then it will be followed by this quick ideation, sorting and voting, similar to day 1, but less complicated and more focused on solutions potentially. Yes, so the agenda is this. I think I've gone through it already. And in the end, we're also going to make sure that we harvest the results and closing, and we're going to see how we nominate one participant from each board so we can conclude and present the results. Okay, so here are our presentations for the 2 first sessions. We have William Ray from Synergize and Hannes Reuter from STAT, and they're gonna respectively have presentations on the Copernicus data space ecosystem. This is the CDSE for anyone who might be unfamiliar with that. And then also Hannes Reuter is going to talk about how they have been exploring and using CDSE for their statistical production. And then I'm going to introduce our first presentation from William. William is an education solutions engineer at Synergize Solutions, which is part of the CDSE consortium. And he's an expert in the utilization of the Sentinel Hub APIs to solve Earth observation applications. William brings over a decade of experience working in Earth observation and GIS. He now focuses on sharing his expertise in Earth observation and using his geographical background to educate and empower new users to unlock the full potential of Earth observation data. So please take it away, William.
Okay, thank you very much, Ludwig. Good morning, everyone. I was going to start my presentation asking who had heard of CDSE, but I think it's been mentioned so many times the last couple of days that I'd actually be more interested. Who has used CDSE in the room? More hands than I expected, that's good. And who hasn't used it? Good, okay, you're the guys I'm here to persuade. Okay, so as you've already heard, CDSE is the primary data access portal for the Sentinel missions and the Copernicus contributing missions, CLMS as well. It's also a place where you can process your data, whether that is time series. This is something which you can very quickly produce, in addition to statistics as well, which you can then visualize either in the Copernicus browser or within your own applications. And using technologies such as the OGC APIs, you can even power your own applications using the outputs from CDSE. So in a nutshell, as we've already heard this morning, CDSE offers you the full archives of Sentinel data. It's also the home of Copernicus land monitoring service data and the Copernicus contributing missions. However, as I've just said, it's not just a data source, it's a place to process your data, whether that's through the Sentinel Hub APIs or the OpenEO APIs, amongst others. And it can be used to power your applications, to visualize the EO data, EO-derived products, but also statistical information. So to kind of show this in action, I've got some lovely screenshots from the Copernicus browser. Here we're looking at the quarterly mosaics from Sentinel-2. You can see, obviously, how the Europe changes through the years. You've got your advancing snow cover, you've got the greening of vegetation in the spring. And in addition, you can also visualize vegetation indexes such as NDVI, like here. But it's not just a continental scale application. You can zoom into a field level. And here you can actually start focusing on the underlying statistics, creating time series plots, histograms, spectral response curves in the Copernicus browser. So here's a really good example. But what I really love about these applications is that you can actually filter by cloud cover. This was something that previously was quite like a manual process, but now you can create a much cleaner, far more useful time series plot for this field of interest. We also have plenty of the Copernicus land monitoring services data sets here. So we've got land cover maps. You can look at the burn scars across Europe. Focusing on urban areas, you have the Urban Atlas data sets. You can look at vegetation productivity over a whole year, but you can also focus on some daily products, such as the leaf area index here. In addition, you can also bring your own data into the platform, either in cloud-optimized GeoTIFF format or ZAR format. Your data would reside within the Copernicus data space ecosystem, either on Cloud Furrows services or the Open Telecom clouds. And you can bring in either satellite imagery that's not available through CDSE, or other data sets such as aerial photography, your own labels, and other derived products that your organization may be generating. I think this was already demonstrated yesterday in several of the presentations. In addition, you can also use the CDSE for large-scale analysis, whether this is looking at scattered areas of interest, such as fields across either a country or the continent, and create time series for these polygons. Or you can actually start generating, say, country or continental scale products with the wall-to-wall features. So, for example, creating land cover maps based on time series data. As already mentioned earlier, we have OpenEO. Here you can either access it through Python, R. There's also a really nice graphical user interface to access this API. And you also have the Jupyter Lab available to you as well. So here you can actually run your processing in the cloud itself. And within this, there's also an excellent repository full of examples that you can use to learn the APIs, but also borrow those examples to create new analyses yourselves. So why is this useful to you? Well, EO data is the perfect data source for statistical analysis due to its large-scale systematic availability. Whether this is on a continental, a global, or even a country scale, the Copernicus data enables precise estimates at a local level, and it's and allows you to regularly monitor your fields of interest or areas of interest throughout the year, generate an annual or multi-annual time series. So now, obviously, with Sentinel missions have been in operation for over a decade. That means we now have a decade of archived data to use and enhance our applications. And probably to finish, CDSC is already being used to power applications. So a really good example of this is the Wikio data viewer, which utilizes data sets that are hosted on the Copernicus database ecosystem. So to finish off, accounts are already available for immediate use. So if you haven't registered for CDSC, I would really recommend you go do that tomorrow when you're traveling back to your offices. And if you are a member state, an organization contract person, or you have specific demands, I really encourage you to reach out to our help desk, and we can see how we can help you guys out. And a really good example of how we collaborate with organizations is Eurostat. So I would like to bring on Hannes from Eurostat, who's going to share some examples.
Yeah, thank you. First, maybe let's see if there's some questions for you, William. Are there any from the audience on CDSC and access to CDSC? Maybe some experience of use? I think, so the amount of data is increasing quite a lot on CDSC. I know the Copernicus Land Monitoring Service are migrating a lot of data there currently, right?
That's correct, yeah.
And other services as well in the Copernicus infrastructure ecosystem?
Sorry, say
other services as well are...
As well, so you also got the Copernicus contributing missions, which are available through the browser, but also API. So that includes all the very high resolution data sets, as well as some of the radar ones as well.
And of course the Sentinels and so on, but that
yes,
you already mentioned.
That goes without saying that, you've got access to the Sentinel 1, 2, 3, 5 missions at several different data processing levels as well.
Yeah, great. We have many questions here. Okay, I start this hand here first.
Thank you. I was wondering, is all the processing, is it all for free, or is there some...
So for individual users, yes, there is some free processing units and quota available on the CDSC. There is a dedicated page in our documentation site for this. But maybe to give you a rough kind of guesstimate of how much quota you have, you could run a NDVI time series for the whole of Austria at 10 meters resolution for a single month with your quota. So it's not an insignificant amount of quota if you're an individual user. But obviously, if you were starting to process more data, that's where you get in contact with us, and we can work together to find a solution that works for all.
Okay, thank you. I think Gracia here has a question as well.
Yeah, I have a question about what is the relationship between this product and Google Earth Engine? Are they complementary, or there are overlaps?
So, you're going to have to...
So with Google Earth Engine, do we do the same thing we are doing with Google Earth Engine, or the two products are sort of complementary? I'm looking for an alternative.
Yeah, so I would describe it as a European alternative to Google Earth Engine. I would argue that with CDSC, that you're guaranteed that you're going to have the service running and operational at least until I think it's either 2029 or 2030 when the contract is complete. But obviously, with the Copernicus missions going into the 2030s and 2040s, this should still be available. And Google Earth Engine, yes, it has its advantages, but I would argue this is a better alternative. You have much more flexibility to visualize the data within your own applications. You're not limited to the Google ecosystem, for example.
Great. Thank you very much, William, and great question, both of you. Okay, so then, as he's almost on the stage and already, we have Hannes going to present a bit on how they use the CDSE and the Eurostat for the purposes of statistical production with the EU Earth observation data. And Hannes is a geoecologist by training and has over 20 years of experience in national and international research organizations. In the European Commission, he works in the GISCO team and tries to bridge technical feasibilities and functional requirements, serving a wider community of European Commission colleagues. He works now as an expert on geospatial issue in the GISCO team in Eurostat.
Yeah.
Take it away.
Thank you. You might recall yesterday, no, 2 days ago it was already, the presentation by my colleague Carla, where we outlined the implementation plan. You know, how do we bring statistical processing and Earth observation processing together? And then we reflected about the IT infrastructure. Yeah, for sure, everybody could think, yeah, we built our own IT infrastructure, statistics does it usually. We could do that for Earth observation as well. But we realized quite quickly we cannot move all this big data to something else. And we know CDSE back then already existed. So we tried to onboard, and then back then we made the business decision. We're trying to bring everyone on CDSE, and together with our colleagues from DG DEFIS, which gave us then preferential access to that one, we tried to bring all our NSI colleagues onto that platform. And now I want to outline in this presentation today here to you to show what we have currently achieved and what we want to go, where we maybe want to go further. So, apologies. We have mentioned a project called AIM for ML, where we're testing various artificial intelligence, machine learning application cases for the statistical data production. And here we had 2 different use cases. On the left side, you see the numbers which we have done for the land cover maps. This is one of the approaches which we're testing. A member state, in that case France, had a land cover model, and this has been applied now to different country data sets. And here we walked our own auto imagery server data sets in CDSE. You might recall, like Wilhelm says, bring your own data. We tested that one, made it, and we made it for the whole country of Austria. We made it for a small region of Denmark, as well as for Italy. And as part of this work, we also planned that for Poland. At the same time, we have done something similar, also for the COPTAP maps. We used Sentinel-1 data, we proved it, run it for Ireland, Sam is somewhere here, there, and also for the Northern Netherlands, the Polish colleagues are in the back, but I don't think, yeah. So we have done work on that one. And then this is a case where you can clearly see it. This Polish model had been running for agriculture statistical production, and they are one of the cases which are already using it, Earth observation, for statistical production. They have run it on their own infrastructure, and they realized, yeah, we can do that. For operational purposes, this is better to move to CDSE, and we are moving them here as well. So that's the reason we are testing here. And yeah, we have to say, is Tim still in the room? And the colleagues from DG DEFIS, we are still grateful that you, thank you, Tim. Really, no, without you and also the whole community from DEFIS and EEA on the CLMS, we could have not done that. Second use case, slightly outside. It's from Turkish. The Turkish have done it as well. And they have worked on the SDG indicator, land consumption per population. And as well, they have worked on fallow land area. And they used a pre-produced land cover map and then process it for the all-over statistical, for their reporting process in 1 day on the CDSE. And they are really grateful. And they have done it. And they also, sorry, back to the SDG, I forgot about that one. They first tested it in Google Earth Engine, and then they thought, here we come back to the question, where do we want to work in the future? Google Earth Engine can be shut down at any given moment, we know, or because it's a commercial service. And do we want to rely as public institutions on something like that? Yes, and this is here I would advise for anyone doing this kind of management decisions not to do so. Anyhow, these were two cases, well, several cases from the member states where we have done so. And last but not least, we just have done completed Lucas master. This implied that we photo interpreted 1 million orthophotos and VHR 2024 images. You just have seen the presentation by Peggy where she was referring to the VHR 2024. We had preliminary access to the data set before this was released, so we could do that work. This is every 10 years. We need to derive the weights for our sampling program for the Lucas. So, and this was in that case where we have done it, and we used the CDSE to extract the number of time series of NDVI to see if we could improve our machine learning predictions for the 4 million points which we have done on that one. And you see here the results, what we derived from as a visualization here over the 3 different quarters. With that one, and because that's a workshop about that one, how many of you are NSIs or NS owners in the room still? Hands up. Okay, thank you. Who has not yet used the CDSE or not applied for an extended account? No? There's one hand. Cool, at least one hand. Whatever. No, we just want to encourage you. Why we put up that slide and why it was important for us to be together with William here on stage to you. You can become a Copernicus service user. And there's a QR code because it's a little bit hidden, this registration page, how you upgrade you. Scan it, put Carla in copy or Estagisco.io, and then we will ensure, together with the colleagues from DEFIS and the service providers there, that you get upgraded account rates, and then you can do your processing there. Yeah, and with that one, thank you for your attention, and I'm handing back to Ludwig. And
thank you very much, Hannes. It was a great presentation. Nice to see some real-world examples of how it can be used in a big scale like that. Before we move on, so any questions to Hannes? Yes, great. Can I get the blue one?
Thank you for your presentation, also William. I was wondering if there have been any privacy-sensitive projects that have been on the CDSE and what the security plan looks like.
Great question. Yeah, you have.
Yeah, I already have a mic, thank you. To my knowledge, yeah, in case you have privacy-sensitive data, William can maybe come to that one. The discussion which we had heard from the member state, they are not to share any of these data outside their ecosystem for the moment. We know several member states have this issue from a legal act. We need to see how we, option 1, we change the legal act, we change the discussion. B, we change the methodology that, sorry, and I don't understand that reasoning from the data privacy officer, you cannot even share the coordinates. You know, not even, we're not talking about attributes, but they're saying even a coordinate is a private issue. So sorry, I mean, then we cannot, sorry, going back to my Lucas example, sorry, here we are extracting for every single point whatever information from an Earth observation source. Then one could think, at least I, in my little mind as Hannes, I would think, let's go and extract all the information I need for my model, which I'm doing at home, at house with all my attributes where I do that. I do all the processing at home, but I at least extract the auxiliary information and feed it into my system. You know? But I mean, this is, some of our NSIs have flagged that as a current issue, and we have not come around it. William, I don't know if you want to come on stage and talk more about security in this one, but I mean, sorry, any computer in the internet is publicly reachable.
Yeah, I mean, it's a known issue. I think it's one what part of one of our rocks which are coming up.
Indeed.
I think it's probably better to speak offline about it. I'm not an expert. I don't want to say anything that gets me in trouble.
Yeah, it's a great question and an important topic indeed. And we're going to discuss it exactly in the exercise as well, where we're going to explore it and try to find solutions, because potentially we need some type of practices established so we can convince the security officers.
Yeah, but I mean, so we know, for example, that certain member states needed to go back and download all the data. So raw data from CDC on their local machines, process it there, because this is what they get told. But I mean, sorry, this is reality. We need to face it like that and just accept it for the moment, and we will see how we as a European statistical system move as well forward with that one. This is one of our business process. Yeah. Sometimes you move 3 steps forward and then 2 steps back, but I mean,
Yeah, exactly. And I agree with you. The sensitivities in the attributes describing the point rather than the point itself. There's too many points to be sensitive. Any other question? Otherwise, we move on. Here.
Thank you. I'm not sure if the question is for the speaker or the previous or someone else, but the scenario of use that I consider most important but is very rarely addressed is not the one where there is a user and a monster, but it's the one where there are federated services. So can this be a beginning of a move towards the ability of a service to use this service in order to provide and potentially be federated with more services? Because the whole issue of quotas and yeah, you can have enough if you don't do too much, this kind of stuff immediately stops that discussion, and I would really like to hear that addressed at some point.
Anyone has an answer there? I think it's a good question on federation. I think that's part of the solution for sure.
Yes. If we're thinking about it, yes, in a vision, I'm speaking from a vision point of view, in a vision, because we have CDC, we have the HPC world, we have the digital twin, but I mean, that's a question as well. You have computing capacity at the HPC, and you have computing capacity also with the digital twins, huge capacities there. And we need to see, but I mean, this is more a strategic vision, which we need to have a discussion at the Commission with the member states together. Where do we want to? I'm not in the position to say we will do that. I mean, sorry, I'm running corporate level services at the Commission, and I see that APIs is the key to go. You make APIs available with the data, and you couple everything together. This is a way to go. Where the data sits, the algorithm travels always to the data. And then we can, maybe at one stage, we can couple everything together and maybe overcome also the quota limit.
Great. Okay, thank you very much, Hannes. I think we move on then to the exercise. And maybe a bit in relation to the last question, should be mentioned as well that there's a framing here where we use CDSC and we describe CDC, but there's also other similar cloud systems, cloud processing systems, like with Creo. You showed an example, you've used the Creo Dias in the past as well. So also for the exercise, we use CDSC, but see it more as an example, right? Because just like the last question, there's federation, so there's a possibility to use many different of these providers, but with the federation, you still can access the data and process it in other infrastructures. Okay, a familiar face is on the stage. Sebastian, you take over here. Yes, and we have the mic here for you. And Sebastian is gonna go through a bit what we're gonna do for the rest of this workshop, or for the exercise that we enter now.
Yeah, hi everyone. So now we're gonna get physical and collaborative. Who was here on the first day? Can you put your hands up? So everyone experienced the first workshop session. So today we're going to actually do what you ended up doing on the first one, which we ended up developing how might we questions, which today we have predefined them, and now the next stage is creating a quick ideation session. And what you see here is pretty much what we will have at the end of the round. So we will go through 3 quick ideation sessions to generate as many ideas as possible, and then we will go through a round of voting on the presented solutions, and then identify some of the boards so that you can say what was your solution to the problem, or the most voted solution. Just recap on principles. What are we doing here? So the way we work is the principle of working together alone. So we are all as a group here together in the room, but you're essentially working on your own using Sharpie pens and a set of Post-its. And you basically have the space like that to develop your ideas without anybody interfering or anybody dominating the conversation. So that's the advantage of doing it this way. The next principle is tangible instead of endless discussion. So instead of trying to convince others of your idea that it's a great idea, we basically all have the space to note down the ideas. And it also avoids different interpretations. So we basically develop the ideas on paper, we stick them on the board, and at the end there will be a voting on what is the way forward. It's also, this third principle is getting started and not being right. So this is really to break the cycle of decision paralysis, which we often see in endless discussion cycles. So it's a very different type of workshop. And the other thing is we're not relying on you to be creative. We're relying on the process that allows you to collaborate and to generate ideas through the process. Okay, just a couple of rules. Please put your devices away so nobody expects your attention right now. We basically have about 40 minutes of, actually how much time? Yeah, a bit more actually, until 12, right? 10:30?
11:30.
11:30, okay. All right, so yeah, about 40 minutes we'll run through it. No devices, please, and the other thing, no judging. So everybody's idea is welcome. Whatever level of hierarchy, if you're introvert or extrovert, everybody's idea is welcome. Just quickly to demonstrate what we're doing. So there's 9 flip chart stations that we've built up at the back. Each one has one of the problems noted down. And we will put you into groups. I will do that in a minute. And then we go through the ideation session. Then you will move to the next board. You will read what other people have written down and sort it, and then create your own ideas to add to that. And each team will basically have 3 boards to work on through the overall session. And at the end, the last group votes on all the ideas that the previous teams have basically left behind as well. Okay, so do you want to present the themes?
Sure. So these are the identified themes for the different stations. As you explained already, there's one predefined, and these are the anchors rocks if we compare to the workshop 1 on day 1. And these stations are so adoption challenges that for.
Actually, I'll go to the next slide, so maybe it's.
Yeah, we can. Yeah. So adoption challenges, and with how might we question make the first experience of CDSC or any other cloud infrastructure so frictionless that the statistical community begins exploring on day 1. And then we have the second station on statistical production. How might we question integrate CDSC seamlessly into the existing statistical production workflows so it adds value without disrupting established processes. And the number 3 is discoverability. Create a single curated catalog that maps CDSC capabilities directly to known statistical use cases. If you go, and then on the Earth observation skills gap, abstract away the complexity of Earth observation processing so statistical producers can work with outputs without mastering the underlying science. Number 5 is data privacy. Design privacy by default processing patterns that NSIs can adopt without custom legal review for each use case. So this is a bit on your question earlier. Political will, demonstrate the concrete value of Earth observation for NSIs through high visibility pilots, results that speak to leadership priorities. And then we have the last 3 ones. IT infrastructure, shift heavy Earth observation processing to CDSE, cloud infrastructure, so NSIs no longer need local hardware capable of running it. That was what Hannes discussed a bit. Number 8 is tools and interfaces. Systematically map the gaps between the CDSE currently, what CDSE currently offers and what statistic workflows actually require. And then the last one, number 9, is missing information products. Run a structured needs elicitation process with NSIs to create a prioritized list of Earth observation-derived statistical products.
Okay, so now we're going to move on to the quick ideation. And can I see who are the volunteers actually for today? Because we need to count you out, so it's hard to determine. So what I would like to do is actually get everybody who's going to join the session to count down to 9. So 1, 2, you're a volunteer? Okay, all right. 3.
Yeah, you move to the side. They already have a number established, so they will be at the board.
Okay, okay. So okay. So so if you could shout out 1, and then the next one in the row, 2, go. 1. You? Hello? Are you joining the workshop? Okay. So 2, 4, 6, 7, 8, 9, 1, 2, 3, 4, 5, and the gentleman next to you is 6, I guess? Okay. 7, 8, let me just walk through it, it's hard to see. Okay.
Remember your number, please.
Yeah, so, yeah, remember your number. So you were 8, 9, did I have you? Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4. Okay. Everyone has their number? Yeah? Okay, so I invite you to please move to the back and find your board. You will see the number on the top of the board. Okay. Okay, it still works when I'm here, yeah? Okay. All right, the volunteers, can you please hand out pens to everyone? And everyone gets a block of these green, the Post-it notes. I hope there's enough space for... Does everyone have the green Post-its and a pen? Oh, I thought everyone was given a number. So if you, go and find where there's no volunteer, I would say. Yeah.
Something like that.
All right, guys, everyone has the material? Does everyone, who's still missing, can you put your hands up if you're still missing pen and paper? Who's missing? Okay, we still need some there.
There's more.
Okay, for everyone that already has the material, look at the question that you have in front of you. So this is a so-called "how might we" question. Shh. Okay, so look at your board that you've been assigned to. This is the first board you will be starting, and then you will be moving on to the next board. So you have a couple of minutes just to digest the question. It's a "how might we" question. So it's phrased like that to basically allow you to generate ideas. And I've given you an example there which is totally non-related. So here at the, on the board, so on the slides. So how might we make public transport so reliable that commuters leave their cars at home? So possible solutions that a group has come up with: real-time bus tracking on street displays, one app, one ticket, every connection, a morning alert if your usual connection is disrupted. So these are possible ideas. And now you need to transfer that same method to the questions in front of you. And everyone should now have a block of green stickies and a marker pen. And what we're looking for is essentially 5 ideas per round. So, and you will get 5 minutes. So we're adding a bit of time pressure. And what I'm asking you is to note down the first idea that comes to your mind on the post-its. And after 1 minute, move to the next post-it. Put it on the board, next post-it, okay? So it's a bit of time pressure, but it doesn't have to be, basically, I'm not looking for the perfect idea. I'm looking for many ideas related to the question in front of you. So everyone has the materials they need? Does everyone have the materials? Yes? Okay. Can we have the timer, guys? Regie? And remember, it's no discussion. It's you note down your own idea on your own sheet, basically. Yeah. Yes, they're in the envelopes. The envelopes are empty. Really? There should be the big one, the big envelopes. Okay. Where's the timer, guys? Okay. Oh. Yeah. Oh, good. Okay, no worries, okay.
Yes, but we have some of the envelopes with the stickers and the other one, they are empty. So we need to check.
Okay, the time is starting now. After 1 minute, I'll ask you to move to the next idea. Yeah? These are the old ones. These are the new ones.
But they are empty.
Move to the next idea. Write down the next idea, please. No, the rotations. Yeah. I will run through it just so it's everyone. It's process. exactly, exactly. No, we will say.
Shall we hand them out
Yeah.
to the volunteers?
Yes. Yeah, exactly. Okay, guys. Next idea. Please move, stick it down, the last idea, and then move to the next idea. You have 1 minute. Until the end. The voting's at the end. So no, they vote on that last block there. The last one. Even on the ideas that we have. Okay, move to the next idea.
So that's clockwise. Yes. Yeah.
No. So. No, so I will instruct when you move. We want the next idea written down. Write down the next idea.
Oh, not yet?
So no, write down the next idea, I said. You will get the, no. You will get the instruction from me when you move. Okay. Yeah. You stay here. Now write the next idea. So stick down your post-it and write down the next idea that comes to mind. Not yet. After this, it's been so many promises.
Yes.
5.
Yeah, here we had, we were waiting, we were anticipating people on the first day. We only had 2 weeks to prepare. Okay, guys, so we finished the first session. Can I have the slides again? Okay, so hopefully every team, every member of the team should have had up to 5 ideas that you put down on your board. And now what I'm going to ask you to do is each team moves clockwise to the next board, and you will then read at what other people have suggested as ideas on that board and start sorting it, clustering it, and just so you see what other people had in terms of ideas, and it will form the basis of the ideas that you will create in the next stage. So can I ask all the teams move one board over? So please digest the question, the how might we question. See what ideas other people had that came before you. If you see any patterns in the ideas, please sort it together and use it as a basis for creating your own ideas, formulating your own ideas. For this one, actually, skip the timer because I was just talking through it. So the next one, yeah, the slides. All right, guys, so we're going to start the next ideation session. So again, every minute, write down an idea and paste it, put it on the board. Something, it could be building on what you've seen the others contributed to before, but it could be a new idea that you think works as well. Okay, can we have the timer? All right, time starting now. Write down the next idea, please. Okay, guys, get ready to write down the next idea on your post-it note and put it on the board. Put down the next idea. Stick the previous idea on the board and write down the next idea on the post-it. So we're looking for quantity here. We will sort the quality later. Move to the last idea now. You have 1 minute to write another idea. Okay, guys, stop writing the ideas. Thank you very much for this. So, can I have everyone's attention? Shh. Okay. We will now move again to the next board. And please, everyone, move to the next board clockwise. And we will give you now 8 minutes to digest the information that other people have left there. If you see any pattern there, any things that could be clustered together, do so. But use it now just to get inspired by what you see, what other people left for that particular question. And, and I will tell you when to start writing the next ideas. But now you have time to just read and digest the information. Start there, yeah. Cluster the information that was provided. You see it in pattern, but use it as inspiration for yourself. Guys, you can cluster the information that you see there. Not yet. I will tell you when to start adding new ideas. So guys, you can start clustering, and I will tell you when to start adding new ideas to this. Yeah. Yeah. In a moment, I will ask you then to add new ideas, but not yet. You can cluster the information that the others provided, so feel free to sort and cluster, and I will tell you when we start the next ideation round. I will tell you when so you have a bit more. Yeah, don't. Yeah, just focus on clustering and understanding what other people have left there, and will tell you when we start the next ideation round. But maybe it inspires you what other people have said. Maybe something is missing. You see that there's a gap that you can add. Okay. It's still established in the workshop world. It's again
I understand.
yeah.
So maybe we should now change the workshop.
Maybe. Yeah. But thank you for the feedback. Yeah.
They're at their last station.
Yeah. So they will get
And
the.
now they're studying sorting.
Yeah.
But they're gonna fix it.
Are they writing as well? Okay.
Yeah. I think that's just natural.
Okay.
So yeah, you can go and never ask everyone
Yeah.
in the ideation. Never move on. But we could give them 5 minutes.
Yeah.
Probably someone is probably sticking to this.
Yeah. Well, it's in this usually you do the workshop like in let's say 10, 12 people.
Yeah.
But here it's hard to control everybody's urge to. Yeah, I think.
It's actually good.
So that's good. It's what we wanted. So
Yeah.
Have the timer? Yeah. I will move on. All right, guys, we're going to move on now to the ideation. So maybe you have identified already some gaps in what other people have seen, other people have left behind as ideas, or you feel like you want to contribute a new idea or add to the gap to improve, let's say, the previous ideas. So again, we're going to go through 5 minutes of ideation, 1 minute per post-it. So just get your ideas out there. Don't overthink it. Just put it down, jot it down on paper, and we will then look at the through the voting that will happen next. What is the best idea that comes out of this? So, can we have the timer? All right, please start. Next idea. Jot down your first idea. The first idea, now ideation. Yes?
Just tell me what I need to.
So everyone has the sheets, and they need to write down the next idea. So
They already have done it. So now.
oh, they have already done it. Okay.
Stay on the same.
Yes, they stay. No. It's the third ideation round because first it was clustering and sorting, and now they put the.
We have done it at the
Okay.
same time. Yeah,
Okay.
Okay.
You moved too fast. Everyone's clear what they
Fill the gaps.
or add something new, or I mean, just what's the first idea that comes to your mind? Just write it down. Everyone's clear what they need to do. Yeah. knows what they need to do, guys? So just add ideas.
Yeah, yeah.
Okay. Everyone, are you all clear what you need to do? Okay. Move to the next idea. Write down the next idea. The next idea, please. Next idea, please. Everybody, next idea. Write down now the last idea. This is the last idea. All right, guys, stop what you're doing. Stop what you're doing. Shh. Okay, so we have now reached the end of round 3 of the quick ideation. So you had the chance to see 3 problems and to help us generate ideas for solving these rocks. And so what we will do now is the voting. So the board that you are on right now, you will have the chance to vote on all the ideas that you and the previous teams have left behind on the board. And for this, the volunteers will hand you 3 voting dots. You will get 3 voting dots each. And in a moment, you will be able to vote on the post-its that you have on the board and identify the idea that you think has the strongest potential in solving that the challenge ahead. So, please try and get voting dots from your volunteers at the boards. No, 3. Every person has 3 voting dots. Every person has 3 voting dots. Can you put your hand up if you're still missing voting dots? Anyone still missing voting dots? Okay. Volunteers, can you please make sure that the post-its stick on the board? It seems like they fall off. Just make sure that they're stuck down.
So it's on post-its. Yeah, of course.
Okay, so yes. Give 5 minutes. 5 minutes. Huh? So you can vote on single ideas, or you can use all your votes on one idea that you think is really great. So it can be your own ideas, but it can be ideas from other people as well. So feel inspired. We will give it 5 minutes for you to read and vote.
Technology.
Exactly. But it's related to
But it could be technology as well. Yeah, it's in between. Yeah. Done voting? Oh, wow. Space. And then you can easily, without moving the data layer, you can connect to the data. And I think you downloaded 40 images and then moved again. You have it. So that's federations. And with metadata and so on, it can be very, if it's properly federated, it's very streamlined. So you essentially just need the endpoint of where you know the data is, like the sequence. But you're at another space, you just connect. And you can search two products. And you say, I want two products for this time period with this band. The federation will make sure that that data is streamed to where you want.
All right, I think I think everyone voted, so. All right, guys, so thank you very much. Shh. 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 All right, so I believe everyone has voted, so we have come to the end. So well done, you did a great job. But before you leave, we have one, we would quickly just get an idea of what the different boards have come up with as kind of good ideas. And I'm just going to randomly, I don't know, group one, can you tell us what the problem was and which one was a good idea from your side?
I think there were a couple of candidates for, let's say, critical items for faster and immediate onboarding. One was make the visualization of the products easier as much as possible for non-expert users. To find a common. The second point is about finding common terminology between to bridge the language gap between the statistician and third observation experts, because they speak a different language, and also a very interesting idea about a chatbot that could help in more interactive way the introduction of the user to the system, in order that he or she is not lost in the plethora of documentation and interface options the system provides.
Thank you. So this was adoption challenges. I'm just going to move here to the next one. Statistical production. What? Who wants to?
Well, what we did here in the group, we clustered it by the different statistical steps of the statistical production, let's say. And we have like a tie. The first one is about speaking the same language. So stats and EO have to speak the same language. So this is kind of in the ideation of the statistical production. And then more to the end of the statistical production, when we are dealing with calculating the accuracy. So clarity to quantify the Earth observation uncertainty, spatially and temporarily explicit. So we have two different winners in different parts of the statistical production.
Okay, great. Thank you very much. So I'm going to move on here to discoverability. Who's?
Yeah.
Okay.
It's me. Yeah, thank you very much. Here we discussed about how to make it easier for statisticians to access. Oh, closer. Okay. How to make it easier for statisticians to access Earth observation data in CDSC. We have a winner. We think it's useful to have more use cases and document use cases and be able to reproduce these use cases in different scenarios for different policies or for different statistics that are required. Okay.
Okay, great. Thank you very much. Do we have time to go for more? Or? Okay. So here, this is the rock on EO skills gap. So.
Yeah, so when we're looking at tackling this rock, we had a real clear winner, which was education, education, education. So there were a lot of people who are very keen for extra workshops for statistical specialists in working with EO data, as well as, I guess, asynchronous trainings as well. But in addition, some people were also quite keen on making EO data kind of more easy to use for, I guess, non-native EO users. So like making EO data invisible. Like, for example, like people use Google Maps day to day. They don't know that they're using GPS in the background. I guess we want the same kind of end goal with EO data. But also wider sharing of algorithms, workflows, and also data as well.
Okay, great. Thank you. So we move on to the ROC data privacy.
Yes, I took over this board. Patrick had to leave for a meeting, but I got nicely introduced by the last group. And there's a clustering here, which is more on, so 3 clusterings. So governance, kind of how to set up governance around handling data privacy issues. And then methodologies to more kind of work around it. For example, transform coordinates to anonymous grid cells and so on. And then the last one is more technologies, kind of develop APIs to ensure data privacy that is maintained. But the winning one is here in governance, and it's to ensure private data space, that there is a data space that ensures privacy on these platforms. So NSI can essentially move data there, knowing that it will be only accessible by them, right? By the ones that should.
Okay, great.
What was that?
Thank you, Ludwig. Yes, we're moving on to the ROC political will.
Political will. The idea here was to ask the people to think about how they would demonstrate to their bosses in the statistical offices that it's worth to invest in EO-based solutions. So we had many ideas. To be honest, it was a bit difficult to cluster them very cleanly. Of course, use cases is the winner. As well of really demonstrating here on what could be the impact in terms of, let's say, simplification, in terms of administration, cost saving, and how, for example, it could contribute to reporting obligations more easily. Also, we had some ideas in terms of cost-benefit analysis, impact, showing the positive impact, both, generally on a technical level as well, and also ideas about how to communicate this, maybe in the context of creating webinars, creating more, let's say, communication-wise, as, let's say, solutions, no? So mostly the winner was more about the demonstration, for example, of how easy it can be to obtain analysis-ready data from CDC, also how money could be saved, or, for example, present specific case studies to their managers. That's a bit it. Thank you.
Okay, thank you. So we're moving on to the ROC IT infrastructure.
So the how might we question here was how might we shift heavy EO processing to CDSC cloud infrastructure so that the NSIs no longer need local hardware that is capable of running it. The largest cluster of ideas by far was about making CDSC more cost and time effective, and also streamlining the experience, making it more simple. But by far the most voted on was to guarantee a long-term capability, so trust in the system, so that it runs for many years, and the experts can go to the head of the NSI and say, we have a commitment here of 10 years, 15, this will be available, because otherwise they cannot propose it as an infrastructure. And then some more minor ideas about the data privacy, which I think we can move to the other board, and linking with more data sources, which could be also beneficial.
Okay, thank you. And we're moving on to tools and interfaces.
That would be me. So the question, or the how might we, was a bit ambiguous. So how do we systematically map the gaps between the CDSE currently offers and statistical workflows? But I think there's a wide variety of ideas on how to come to a solution for that. But there were 2 clear winners. One was that we need more tools to integrate the existing workflows. So you have the different building blocks, and you want to integrate the data flow between those building blocks into one orchestrated workflow, for instance. So we need tools for that. And another one was to apply, or try to apply, the SDMX standard. So this is the standard statisticians use to disseminate statistical data, and see if we can apply it to EO data as well, or how do how does it relate to the data that flows between the workflows? So were the winning ideas.
Great, thank you very much. And Hannes, with...
Last but not least, on missing information products. The clear winner is here around population estimates, census data, and the question really is, are we as statistical organizations sharing all our microdata, what we call microdata, what someone else would call reference or in situ data, with the Earth observation world? So, and do we include other geospatial sources, social media, traffic, transport flow, and data sets also into this one? Just a question. This gets a clear winner here. And then the other one of missing information products is semantic interoperability, harmonized nomenclature. You all know that the agriculture classification in country A is different than in country B, or in one country we even have in the Ajax data set, we have 4 different classifications. So thank you for that one. So this is the second one, and yeah, better temporal resolution is for the second winner. We have just 2 different ones. Thank you. Back to.
Okay, great. Thank you very much. So you did a great job. Thank you. So this concludes this workshop. And you are now free. I think the next thing is lunch, right? So.
No. Sorry, colleagues. Stay. If you want to stay with us, if you want to stay with me, Jose, Timo, where are you? We have a coffee break now, and then afterwards we have a workshop on in situ discussions. So you're welcome to stay. So coffee break for the moment. Thank you. Dear colleagues, may I ask you to take the seat, please? Stop talking. Drinking coffee is still allowed, but not talking with your neighbors for the moment, because we're already 10 minutes late or 15 minutes late. It's fine. Come on. Have a seat, have a seat. While designing this conference, and we had a reflection on the workshops, and you had also seen on the workshop on day number 1, in situ reference data was quite high on the agenda. So we were quite proud that we designed that workshop here. And just to frame it a little bit in the beginning, what we want to give you is 3 presentations from the different environmental or statistical data centers which you have in the European Union ecosystem. One is Eurostat for the statistical data production. Then we have the Environmental Agency, as well as the GRC, because the data center for forest and soil is hosted in the GRC. Just to give you this as an old concept, it predates 30 years of work. Probably, I see someone nodding who's much longer in the Commission than me. But we realize in our daily conversation that sometimes people do not know about that one. And that's the reason is why we will give you 3 presentations, one given by me, sorry you have me on stage, then one by Timo from GRC, and then one from EEA. So, and then we will have a group exercise, sorry. Similar what you have seen, where we want to have 2 points, main points per question. It's an exercise framing, report, harvest, and closing, and you know the drill. We are now on day number 3, so you all know that, and I can go over. So you will have the next 3 speakers, me, Hannes Reuter from Eurostat, Timo, and Jose. I will not introduce Timo and Jose. You will see them on stage, what they were doing. So, let's go directly into the topic, Eurostat's geospatial reference data sets, and I will put up a slide just to put ourselves in perspective. You might have seen that slide already in the beginning of the process, where we introduced the Global Statistical Geospatial Framework. Because what do we want in the end? Like Raphael said, we need a table. Why do we need to have a table? We need to make a political decision, and we need to evaluate if a legal instrument which we introduced to reach a certain status with our natural environment has been successful or not. So, and that's in the end decision making. And this is also why we have the Global Statistical Business Project Management there. Earth observation comes into that game, as well as other auxiliary data sources. And I just want to give a couple of examples which kind of auxiliary in situ reference data sets are coming from Eurostat in that respect. Do I need to do something here? No? No? Good. So what's GISCO? Thank you. So what's GISCO? GISCO stands for the Geographic Information System of the Commission. And we provide reference geographical information. What does it mean? It's all kind of reference data sets. Starts with something stupid, or not stupid, but really simple, like country data sets. Goes down to the statistical units you're all aggregating, being it the NUTS or the LAO data sets for the census. And we also provide different geospatial infrastructures on top of that one. And with that one, we answer the needs from the Commission, even public citizens, Eurostat, to do that. So here, for example, on the right top, you see the population grid, 1 kilometer which we are providing, or the railway lines by track gauge across Europe. This is kind of sometimes auxiliary information which the Earth observation community might think about it. We might not really need it, but this is you need this kind of semantic information to actually train it, and that's the reason why we're producing that one. So, in due respect with that one, we produce reference geospatial data sets. And this is kind of like the LAOs, local administrative units. This is harmonized administrative units across the European Union. We provide different typologies for policy reporting, NUTS, as already mentioned, population grid, and you see it here, just visualizations. Next to that one, we also provide other data sets. Oh, there's an animation missing, like population clusters, ports, airports, location, distance matrices in between, utility service like education and healthcare location, postal codes, addresses and buildings. And auto imagery. We run for the whole European Commission an auto imagery service where we combine all the data sources from the member states. So I apologize for the non-moving animations because this should show you all the different data sets we are providing. Next to that one, we also do some other data sets, like agriculture census data set. For example, for location, main activities, livestock, education, and labor force. And you see here examples where the colleagues in Eurostat have worked together with the colleagues in GRC, applied statistical disclosure control, because farms, if a grid cell has less than 10 farms, we cannot show them and we cannot even visually display it. And so this is just to give you an example of kind of microdata available at the NSI level or at Eurostat for analytics. So you can have looks at farm size, grassland share per farm or per square kilometer, livestock, how many pigs are living, actually that one. You cannot detect the number of pigs from Earth observation. Prove me wrong. Oh, I see my Dutch colleagues here. Marco is challenging me. Fine, I'm doing that one. A bottle of champagne if you prove me how you count pigs in a stable from above. Okay, on manager age, because there's a second survey in the European Union, the Silk survey, where we are actually looking at education and other things. Next one, and this is, I think, the most known to you, and I can probably go quickly over that one, is the Lucas survey. You all know that it's about around every 3 years. We're doing that one. The next one is planned for 2027. And it's a land cover and land use survey, and we plan to send around over 100,000, sample over 100,000 points in the next campaign with the different components. So, and for that one, we have just finished the Lucas master preparation, what I mentioned earlier in the workshop before, where we sampled, photo-interpreted 1 million points, and then which is informing our sampling campaign for next year. And with that one, just to give you an example, these are the results on the 2 kilometer grid, 1 million points photo-interpreted by 2 people, double-blind, quality control, and then you can actually do something nice. I couldn't resist to include that in the slide now. What you can do, you can use a machine learning with a wide breadth net machine modeling thing, and you can actually do it at every square kilometer. And with that one, we have used our auto imagery service, and we have created 500 by 500 meter auto imagery subsets for every 1 kilometer location in the European Union. I conclude with that one, just giving you a slight overview. We're providing the founding elements for the implementation of the Global Statistical Geospatial Framework in the European Union, also for Earth observation. We have a wide variety of geospatial data sets available for you. We focus mainly on administrative core reference data sets, and you will see how our data sets are, or data centers are complementary to that one. And we focus on authoritative data sets coming from national authoritative institutions. There are other data sets around, which is collected differently, but we focus on that one. And with that one, I hand over to Timo. Thank you.
Yes, so hello everyone, I'm Timo Brera from the Joint Research Center, and I'll present you some of the JRC products that, based on in-situ data for agriculture and forestry, representing the work of many colleagues here today. And each slide contains some info, so in case you're interested, you can look it up. So for those not familiar to the JRC, very brief slide about that we're the independent knowledge and science service of the Commission, and we collaborate with Eurostat and the policy DGs to support evidence-based policy in the European Union. And the work I present today is specifically from the land and climate, food security and disaster risk management colleagues. So the first one was already mentioned as well on the first day. So it's Lucas Copernicus. So the Lucas survey is actually, its aim is to create aerial-based statistics. And this data set kind of tried to make the Earth observation ready by creating homogeneous polygons that represent a certain amount of 10-meter pixels, which are then, also have undergone quality assessment and control. And in total, there's like 60,000 polygons collected, representing around 47 million agricultural parcels across the EU. Then the second one is Lucas Soil. So since 2009, for a subset of the Lucas survey, topsoil surveys have been collected. And this is the first attempt in Europe at a harmonized European soil cover database. So all these samples have undergone the same analytical procedures in a single laboratory. And at the European Soil Data Center, these samples are archived, the data is quality checked, and some EU-wide analysis are done for soil function assessment. Then there's the European Monitoring of Biodiversity in Agricultural Landscapes. So this is this was commissioned by the Directorate General of Environment, and it's a Lucas compatible survey that is done on 500 by 500 meter grids during the peak phenological period across the EU with 27 member states. And in this plot, there's various landscape elements, habitat types, plot scale biodiversity, and pollination resources data collected. Then there's Eurocrops V2. So this is a compilation of multi-annual parcel declarations from the national paying agencies. And it represents 3 years across 12 member states. And each record includes crop type, parcel geometry, and metadata that have then also been standardized according to the hierarchical crop and agriculture taxonomy, which then allows for interoperability between, with other data sets. Then there's the DEFID2, so on to the forestry. So this is around 650,000 either polygon or point samples that have been collected from European forests, specifically on the disturbance due to disease outbreaks or insects. It's quite a long record. It goes from 1963 to 2021. And it also includes some quality labels, such as the severity and type of, let's say, disturbance, but also climate-related context and silvicultural practices, and then eventually maybe a sanitation procedure that was implemented in order to control it. And these have also accompanying satellite-derived data, such as the normalized burn ratio or other data derived from Landsat. And then lastly, there's the FIS fire database. So this is the European harmonized database on forest fires. And its aim is to analyze, let's say, the frequency and the occurrence. And there's also data on, let's say, the effect of it, so erosion or emissions and vegetation disturbance. And this is actually slightly wider across not only in the EU, but also let's say, North Africa and the Middle East. And then, yeah, to feed into the discussion for the breakout group later, put some common issues here that you're quite familiar with as well, probably, and that link to some of the data sets that are presented. So there can be a mismatch between the footprint and the EO-based footprint when we're talking about in-situ data, the spatial representativeness, or the variety in the basic unit of analysis, so what has been measured and with which protocols. And then, of course, the well-developed metadata as well, such as for the activity reporting in the Eurocrops V2. So looking forward to the breakout group, and I give the word over to Jose from the EA.
Thank you, Timo, and almost good afternoon already. So I'm Jose Miguel Rubio. I work as coordinator of the Copernicus In-Situ component at the European Environment Agency, which is the third leg of this Troika today, organizing this workshop. In my next 8 minutes, I could not go through everything that we do at EA when it comes to reference data. So I decided to focus on three key aspects of our tasks when it comes to management, publication, and use of reference data. I'm sure you are familiar with the EA, what is our role. It's an European Union agency with the headquarters in Copenhagen, which the main goal is to provide information, data about environment and climate to inform decision-making, particularly when it comes to sustainability in Europe. And that's basically our first role, to act as an environmental data hub. But the EA has a very important role in the context of the Copernicus component of the space program. We heard Usue yesterday. We are in charge of the pan-European products of the Copernicus Land Monitoring Service, together with the GRC for the global part. But also, maybe less known for you, is the role of coordination of the Copernicus In-Situ component. So I will go quickly through these three aspects. But first, our core task is, as I said before, provide insights about the state of environment in Europe. And for that, the EA does not collect data on the ground, but actually relies on the data that the different member states, our network of countries, provide. IONET network, I'm sure you have heard about it. We are very happy because we have now a new member, Moldova, which joined in March. And we are now 39 countries across Europe, not only EU, but also EFTA countries and other countries as well. So how do we collect this data from the countries, and in which context? We are supporting the Commission when it comes to the reporting obligation related to environmental and climate legislation. So countries need to report, and then we manage a platform called ReportNet. Maybe some of you have been working with that. ReportNet is what we call an e-reporting platform, which is facilitating countries to provide the data related to the different reporting obligations to the EU. And based on that, we managed to have all the information from the countries that we need to prepare final products, indicators across different topics. You cannot possibly see, it's very small, I'm sorry, but well, we manage a total of more than 150 data flows, meaning, let's say reporting obligations, which cover different domains from air pollution, biodiversity, industrial pollution, climate change mitigation and energy, and so on, and water management, of course, and so on and so forth. With that, of course, all the different reporting obligations have different frequencies. Some are yearly, some are continuous, some are every 6 years. I'm thinking about Birds and Habitats Directive. In all this, we use it for creating pan-European data sets that are made available publicly, but also indicators and reports, assessments that then are provided to the public and the decision makers. We make available we made available, or we are making available all this information through what we call the EA Data Hub, which is providing this access to the data and the metadata over, as I said, a number of topics in legislation related to environment, climate, and sustainability. Again, you cannot see, but I guess you will get the slides later on, but you will see what are the key data sets, let's say the top data sets downloaded through our data hub, related, for example, to Natura 2000 or ETS and also greenhouse gas emissions. These do not include Copernicus because we are also facilitating this via the CDSC. But we are also, of course, tracking how these data are used in literature, scientific literature, and there, of course, our Copernicus Land products are the masters, and we are very happy to see how they are used across different projects. The second topic that I wanted to mention is the role that EA has in the context of coordination of Copernicus in situ activities. That's my real, let's say, my main job, and I'm very happy to have here over the 3 days how important in situ data is in this context, because actually my job is to preach about the value of in situ data in Earth observations. And of course, Copernicus as an Earth observation program is of course relying on a number of many in situ data across all the different topics. I cannot have time to go through all of them. But of course, unlike the satellite constellation that we have, Sentinels, we don't have in situ data collected by Copernicus, but we rely on member states. We rely on a number of in situ data providers, academia, public authorities, private institutions. And even if each of the different services try to get the data on their own, the EA tries to coordinate this process. And among the different tasks that we have, one very important is to understand what is the state of play of and the main challenges and gaps when it comes to in situ data in Copernicus. Some of the topics here you have seen, and you are very familiar, no? Difficulties in access conditions, use restrictions, insufficient spatial coverage, fragmentation, lack of alignment between Earth observation requirements and what the in situ data providers are doing, and so on and so forth. I will not go into all details. We will discuss that in our workshop later. Another of the activities that we do as part of our coordination is the management of Corda. You may have heard about it. It's a platform which is collecting, it's really a catalog to chip into the national and regional authoritative geospatial datasets that can be used in the mapping services of Copernicus. Currently, it's not an open platform, sorry to say so, because some of the data are only provided for the use of Copernicus services, but we are going to start very soon an evolution project where we want to improve the data hosting capacities, creating a geospatial data lake, having a more user-friendly, let's say, front-end, thinking into scaling up Corda to wider use, not only for Copernicus, of course, depending on, we need to also take into account the data restrictions considerations. Just to give you a bit of a glimpse of which kind of data we provide through Corda, of course, essential and very useful reference data like LiDAR, digital elevation models, buildings, wetlands, LPIS, Earth imagery. We also harmonize some of these topics into databases in order to make easier for the Copernicus service to use data from different countries in a common data model. You see here which topics are covered. And the last but not least, of course, Usue mentioned that yesterday. I will not go into detail. We are managing the pan-European products of CLMS, with a number of products, which I'm very happy to see how they are used in all the different presentations yesterday and the day before. But of course, we rely for that on reference data, and that's my last slide. Of course, CLMS relies on many different situ data. We are speaking about land cover, land use, agricultural data sets, of course, Lucas, typical geospatial reference data sets like, let's say, what we could see in Annex 1 of the Inspire Directive, thematic data sets. But of course, we also encounter a number of issues when using these reference data sets, and I guess we will be discussing this. And of course, key gaps that we see that we need to let's say, work more towards having more access to if we want to evolve our CLMS portfolio. We are thinking, of course, on getting more access to NFI datasets, more datasets which are, let's say, at parcel level. And of course, ultimately, we all need consistent pan-European datasets which are delivered on a regular basis, on a predictable basis, because we are an operational program. So I'll leave it here just to give you a glimpse of our activities. So I hand over back to our Master of Ceremonies, Hannes Reuter, which will guide us through the more interactive part of the workshop. Thank you.
Thank you. Just a question for the room. Anyone has a question to the three introductory presentations for clarification? There's a hand up. Oh, no. No? Everybody's fine? Question for clarification? No? Okay, good. You are getting a microphone.
So a question about the last presentation. Thank you for the presentation. It's about citizen science.
Yes.
Do you also participate or facilitate in citizen science projects to gather in-situ data, and what's your experience with the results? So that's it.
Well, I have to say, in my previous life, outside the Copernicus program, I used to work as the co-chair of the interest group of the EPA network, the network of environmental protection agencies on citizen science. So I'm quite familiar with projects which are done by the different environmental protection agencies, or in which they are, let's say, users. So that gave me a bit of a glimpse of this. Now, thinking now how we can include this in Copernicus, we are actually, as part of a collaboration between CLMS and the coordination of Copernicus Institute component, we recently kick off, let's say, a crowdsourcing project called Mowing Quest. You will hear a bit more in the future with colleagues, I think maybe they are around EASA and other companies, to collect data on mowing events. It's a pilot that we will run next year. The idea is to collect data that then we can see whether we can use it as part of production or validation. We need to see as part of our HRL grassland. Yeah, Luca is somewhere there. So the idea is to see, can we get from citizens crowdsourcing data that then we can use in operational context? And if this works, I think we are open to explore this in the future, particularly in the next phase of Copernicus. That's an example.
Timo, you want to come in as well on that one, or no? No? Good. Then we leave it here. Sorry, then.
Fine.
Thank you. Another question. In the interest of time, I would just to introduce you now our 4 different breakout groups. I just somehow counted that we are something like 55 people. So we would like to see that we are getting 10 people per board, so or even less, because we have double hanged them, so maybe if you can find 6, 8, then we divide it up. And we have 4 different questions here, prepared for this workshop, and I'm reading them out. One of the questions is, what data sets are missing from reference data in situ at EU level, at national level? We're phrasing that question to you because you have heard now, you're all informed what kind of data sets are available. Maybe there's something missing out of that room. Artus and Luca will chair these boards. We have 2 boards with this question at the back. Then we have a second question, which agreements governance needs to be in place to get the required data sets. Christina and Jose will guiding these boards for discussion. Then we have a third question which we'd like to work with you on is, do we need a single or a federated data repository for reference data at national, at EU level? We will have Sam there and Pavel there over there, which will be guiding these two boards which we have for that one. And then we have number 4, which will be headed by Timo and Marco here, in situ requirements for statistical processing. And we have split them up as a kind of framing what kind of temporal, spatial, semantic, or governance questions are add on to that one. This can go down into several subgroups while we are talked about producing this workshop. It could go in the direction of soil, in agriculture, land use, any other theme, because as Timo pointed out rightfully, every use case might have different requirements, especially for the statistical data processing. Having said that one, here are some further questions for the breakout group 2, which agreements, governance, frameworks, but I think we stop on that one. What we would like you now, we don't give you numbers. We let you decide freely. So our colleagues will stand at the poster boards, and I ask them please to now go to the poster boards, and you as participants come there and choose which question you want to work on. What the idea is that you will work, and you have worked quite successfully over the last couple of days on that one. You write down ideas, you stick them on, sort them, discuss them, and we will give you something like 15 minutes from that one. After that one, we will put up a timer here to do that. Then after 15 minutes, we ask you to go to the different board, and you do the same there. And then we come back for a wrap-up discussion and voting session with all of you. So please, everyone to the back and choose a question which you want to work on. Thank you. So I see still people are resistant to our request, so please come to the back so the people can work with you together. 3 minutes to go. So, dear colleagues, thank you for the work in the group which you have chosen. I would like to request you now that you go to the next question which is of interest to you. Choose one which you are maybe most unfamiliar and most hated and go there, and then you do the same there again. 5 minutes ideation, stick it, and start discussing. Can I get a 15-minute timer, please? Thank you. 1 minute to go. I hope you have all clustered and discussed your post-its. If you have not done so, then please start now. Clustering, getting them together in 1 minute, if you have not started yet. But I see several of you have already done so. Just a reminder. Could I get the slide back, please? Hello. Okay. Dear colleagues, may I have your attention, please? Hello. Your supervisors have now the red stickers in the hand. I hope everybody has one. Yes, here's one, there's one, here's one. Jose also has the stickers. Yes, please distribute the stickers. And you have now 2 minutes to reflect and put, please, the stickers on the board. And then let's see. The last board you were on. You can only vote on the last board. And let's see. We can also say two stickers per person. 2 stickers per person, please. I think I need a second. We need a second microphone. So if you placed your stickers, see, maybe have a discussion if these stickers are making sense to you. I give you 2 minutes for that one on your board. How are everybody? Everybody still, someone needs to distribute some points. Everybody has put his red stickers on the boards? Okay, cool. Then let's please all come together here to poster board number 1. Come over here. No? You haven't voted, Paul. Apologies. You have? Does someone has please 2 votes for a spare one for Paul here? Everybody has voted? I don't want to leave anyone out. Okay, so it will be on the slides there already, what we are discussing now. So the big question is, which data sets are missing from reference data in C2 at EU level or at national level? So please,
Thank
Luca.
you. Yes, we have harvested, I guess, more than 20 proposals here. We have also clustered based on the thematic or the area of interest, crop, forest, grasslands, water, coastal zones, dunes, livestock, and mobility, emissions. But we have 2 winners, I think. One is national forest inventories to make available at the European level. And the other one is AJAX, so agricultural information for the entire Europe.
Thank you for that one. So this goes in the direction we already have public available administrative registers, which we don't have access to. Thank you.
Yep.
So everybody agrees to that one? Everyone wants to have an opposing vote to that? No? Then thank you. We go to...
Thank you very much.
Number 2. Where is board number 2? Over there.
Okay, so I have the very important question, but apparently not very attractive for most of you, which was which agreements and governance frameworks need to be put in place so we can actually get access to the reference data that we need in the context of Earth observation for statistics. But we had very few but very clever and very good participants in the 2 rounds. And we have a few clusters. One is more related to the enforcing of a sharing of reference data collected with EU money or national public funding. There are a few which are very similar. Of course, we need to enforce, but we need to monitor that this is really happening. It's not just enough to have a legal provision. There is another cluster more related about programmatic aspects of resourcing reference data for calibration, validation, training, also for long-term planning of campaigns such as Lucas, we discussed before. There's another cluster more related on how to use, the importance of use, let's say, to manage properly privacy or data which is a bit sensitive data, how to manage the data privacy. So there are some proposals related to the use of new technologies like federated learning to facilitating the access to this data when it can be sensitive. It needs something that needs to be embedded in the framework. Other cluster is more about creative incentives for local researchers to share reference data. And the last one, we had, of course, something which is related to another question, which is the need to set up a unique hub to upload reference data or federating the different repositories. And also very important as well, the importance of enforcing standards. So these are the clusters, just for Ludwig, I think, to write. But I think the 2 main messages is, first of all, this idea of federating or enforcing or creating a framework to federate the existing repositories to facilitate access to the data. And the second one is related to enforcing sharing of reference data collected with EU or national public funding and monitor this sharing. I think that's the 2 these are the two main messages. Yeah, you can write federation of reference data repositories, and then the second one is enforcing sharing of public funded, let's say, data, we can say, and monitoring, sharing and monitoring that enforcement, let's say. Okay?
Thank you, Jose.
You're welcome.
So we have, everybody agrees? Everybody has a minority vote on that one? Opposition? No? Good. Then, thank you. We move on to the board number 3, which is, I don't know. No, this is number 4 here. I think we need to go back there to Pavel and Sam. So, please.
Thank you, Hannes. So, our question was, do we need a single federated data repository for reference data at national or /EU level? I think most people in the room would say that we do, so the answer is obviously yes. Well, I think yes, most people think yes. We clustered into yes, but how, and we then also clustered into why. The yes cluster, we had one single argument saying no, and the reason that we would say no in this case is because we first need a federated metadata repository, so that should come first. But the yes won out. I think for why, I think the reasons why we would need such a big round-trip data set are quite clear to anyone that works with Earth observation data. So the how is really a good bit more pertinent, I would say. So just some of the proposed hows. I guess one of them is to mandate the data set by regulation as a way to just force member states to engage and start to produce such a data set. I think one of the questions around how is whether it should be bottom-up, national data sets go to the EU, or does it go the other way around? The EU defines the typologies, the reporting requirements, and then the member states provide. So would it be kind of like a model like the Korean model, where the member states collect compile the data and then give it over to the EEA? What else? So create an ecosystem, like have it on the CDSE as a place for it to kind of reside. The JRC to assess current policies for which in-situ data should be a must-have. So there's a lot of policies out there that require mapping, but they don't specify anything around. They don't necessarily specify anything around validation with in-situ data, but it should be apparent in any case from that such regulations and policies that it should be done. And yeah, let's see, I think we're more or less there. So
okay, so what are the two main messages to take home? Do why?
Yeah, cluster on the how and the why. Yeah. So if I want, we can talk. Sure, we might as well talk about the why. So one big one is that it improves trust. It removes a barrier to the uptake of Earth observation data.
I see a really nice sentence here, or posted here, to guarantee, and I see that has the most number of votes here, to guarantee fast, easy access to users at all levels as one of the outcome from that one. But I mean, that's less to do with, But I mean, that's a general overarching question, I would say, but still under that one.
We have harmonization and comparability, of course. So
yeah. Good. Then we leave it as with harmonization and comparability advice as well.
Yeah.
Thank you, Sam. Anyone wants to add something here? What are we missing? No? Then we go to number 4, Marco and Timo will brief us
On
how
number
they
4,
clustered.
which is on in situ requirements for statistical processing. So what kind of requirements do we impose on the data sets that we use for making statistics out of Earth observation data? And there were some themes emerging. One was on the design of the sample, like how do you sample geographically in a consistent way. So we need consistent sampling schemes. One of the ideas also was on more samples for uncommon land use types. So we had a second theme that was gathered around the geolocation. So we need more accurate geolocations of the in-situ data that's allocated, and then we need precise instructions, but that's also in the protocol for how to delineate your the point that you're gathering information about. We had a cluster on the temporal aspects of the in-situ data that we collect or that we need. So some strict regulations are needed on the temporal aspects of the data. We need to validate that it's collected at the right moment. There was an important one on the protocol that goes out to the people going out collecting the in-situ data. It's very important to have strict protocols for people who gather the information, standardized technologies, maybe standardized app, standardized instruction for soil depth, things like that. Then we had a separate cluster which was on the nomenclature. I think it's been mentioned already before, also for the other themes, that it's very important to have that we talk about the same thing and that we define what we are interested in the same way, so that people who are gathering the data all know what to look out for and how to classify it. It's very difficult, often open for debate, but also important to verify to have good quality data. And then we had an out-of-the-box section. So one of these was, for instance, on, let's see, the legal framework. So can you actually go on the territory that you need to do the sample on? And this one was on the centrally processed and distributed for all member states, so the availability of the data sets also already been discussed in the other groups, I think. But if we look on where the most of the votes go, they would be in the protocol, so that we need good and established protocols so that everybody agrees on what's been gathered, and also on the temporal validity of the data. Is there anything you'd like to add, Timo, maybe?
Yeah, just really short, thank you, Marco. Yeah, and all the participants. Yeah, just a really short one. Maybe on the third cluster also represents, I think, the concern to, yeah, that the in-situ data also would be used to detect trends. It's kind of the underlying, let's say, common denominator of those, the three clusters that we grouped in one large one, with the protocol, the geolocation, and the validity. Yeah, many of the participants were.
Okay. Thank you very much, you both. Thank you very much, everyone who participated in that workshop. I think with that one, we even 7 minutes before, or 8 minutes, or 10 minutes before final closure. Thank you, everyone, for attending this workshop and for this nice conclusions for every board. With that one, everybody gives us an applause. Thank you, Jose, Timo, presenting, organizing the workshop, all the colleagues who have helped out from the NSIs and which we were volunteering today here to help us out. And with that one, have a nice day, lunch, and we see after the lunch again. Thank you.
Oh, great. During the presentation, the Eurocrop.
That was fun.
Oh, great. Oh, that's good. Yes. No, I asked Marijn specifically. I thought let's get some input because it's but it's also been bit less solo. It's too loud.
Thank you.
I have to keep the screen, or with you finished?
Yes. You can remove it now. I will come with my stick and
Okay, I save it for the moment, so I can give it to you.
Lotte? Heb je? Heb je? Ah.
Prova, 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 prova. Vai. Prova, prova, prova. Prova, prova, prova. Si sente? Sì, sì, mi sto sentendo solo.
Check. Check. Non ho sentito, non c'è stato una. Check. 1, 2, 1, 2. Check. 1, 2, 1, 2. Comunque il volume era alto qua. Ecco perché fischiamo, sì. Marco?
Hello, hello, hello. Please take a seat. We are about to start. I will check for a second if still people are at the coffee and should come. Please take a seat. Okay. Can you all please take a seat? Then we can start. So welcome all to the workshops. As you can see to the title, From Pixels to Statistics. It's a small group. It's a big hall, but not many people. But okay, that's not a big deal. I think that a lot of people already had to catch that plane. So the next 90 minutes, we will have this workshop From Pixels to Statistics. We will start with a presentation. So Marco is actually the organizer, and I'm just the facilitator today. And we got help from Ivana, from Zach, and from Anatol. Where is Anatol? Okay. After the presentation, okay. After the presentation, we will have a group work, and you already see 8 boards on the site. During the presentation, Marco will also explain what the group work is all about. And Ivana is already giving out post-its with the group number, but I will explain that after the presentation. So please take a seat and let's enjoy the presentation of Marco. Can we have some silence in the room, please? Thank you. Marco.
Thank you, Remco. So this workshop had as a title, From Pixels to Statistics, Working Towards Validated Earth Observation and In-situ Data Integration Practices. But before we start moving forward, I'd like to take a step back because I'd like to emphasize the perspective of the statistician. So as a statistician, what is our bread and butter? I started working for Statistics Netherlands over 30 years ago, and our main product was a big book that had all these tables in the book on all kinds of statistical topics. That was what we made. So we made tables and we put them in a book, and we were very happy that our friends and neighbors all received the book and put them in the bookshelf, and that was what we did. But still, we think that our main product is tables. It's not maps, it's not Earth observation data products. Our main product are tables that policymakers, people from universities, researchers use in their work. And we make them as transparent as possible, but still our bread and butter as statisticians are tables. But we do use geospatial data, and we do have need of geospatial data. And with this geospatial data, we try to estimate indicators. So that could be amount or acreage or a percentage of indicators like biomass, crop yield, land use. We've seen all kinds of examples that we can use to regionalize our statistics or to make an inventory of the things that we need to measure. We do that most often on a country level, but also we try to zoom in more, for instance, on the NUTS 2 or 3 level, sometimes on the city district or neighborhood level, and sometimes even on a parcel level. But most of the time we use higher aggregates of regional levels to aggregate our data to. The same goes for the temporal aspect of the data that we publish. So we do have data most often published on a yearly basis. And if we get lucky, if we get really good data, then we may even be able to put out quarterly data or even monthly data, but we will almost never put out daily data. We leave that to others. So as statisticians, we aggregate towards a certain regional level, and we aggregate towards a certain temporal level. I'm not sure why the slide went forward. With it, so with those aggregated data sets, we can create a map, or we can use geocoded data that classifies areas or parcels or grid cells or addresses. And for that, we can use it as a sort of inventory to create our final tables. So we do make use of geospatial data. In-between product could be a map or geocoded data, but in the end, we work towards the tables. So if we create an inventory, we need to determine the extent or the shape of the parcel that we're interested in. We need to determine what level or what class or what amount the specific parcel or grid or point cell has. And we do that sometimes by manual coding, not often, but sometimes we do. We do it by inferences or using heuristics to infer a certain value, like a land use value. We do use statistical models. So we have a variety of methods available to infer a value for the geospatial data for a specific extent that we want to use for a statistic. There is a wide variety, of course, of spatial data sources, and I'm sure that in the past couple of days you will have seen many of them passing by as a data source that you use for inferring certain values. So obviously we're here for Earth observation data, so that could be one specific spatial data source. But other data sources that we typically could use are digital maps, like topographical maps, geocoded administrative systems, so administrative system that, for instance, code on the address level. We do have access maybe to measuring stations for air quality or for water flow or what have you. We can use fieldwork based data sources, so for biodiversity, for instance, the biologists that go out and measure how healthy the forests are. As statisticians, we're very used to work with survey data, and more often than not, we can link them to individuals who live on a certain location or companies that work on a certain location. So survey data too can be geocoded. We may use regional statistics, so we may aggregate toward a certain level and so know something about the characteristics of a city, for instance, so how high the unemployment rate is, or how many energy expensive houses we have. So we can also make use of regional statistics. We consider it as a spatial data source. And of course, we could also use models, or 3D models, graphs. It's my personal favorite, but I will not go into that because then I'll be here tomorrow morning and the hall will be empty. But using those data sources, our experience, and I'm quite sure that you share this experience, that the data we are using is not made for this statistical purpose specifically. So more often than not, the data does not match with the statistic that we want to produce. So, for instance, if we're using Earth observation pixel or raster, we need to transform it, for instance, to crop yield on a NUTS 2 level. So we need to transform the information we have from those raster cells towards a new extent or support of a spatial geographical delineation. Obviously, measuring stations, of course, they measure hourly values, but if you want to measure the air quality per city districts, then you need some knowledge, model, what have you, to extrapolate or interpolate this information towards the city district level. So what we learn, what we see is that the data that we are using or are able to use rarely matches with what we want to have, and that for that, if we want to use it, transformations are needed. And the transformations is all what this workshop is all about. So we'll zoom into the spatial geographical transformations that we need for making statisticians. So to conclude this slide, as statisticians, we are often forced to estimate quantities, values, on extents or supports where they were never were directly observed. So looking into the data sources that we can use, they may have different supports, and we'll go into the different supports in the next slide to a bigger degree. But with different supports, we mean that we can have different spatial extents like city borders or a raster or a point or different like a safety region or a water region and a city municipality. So we have data on different supports that we need to integrate. We also, to a big extent, I think, discussed that the values that we get from our in-situ data or other data sources more often than not do match the concept that we as statisticians need to produce. So there is always a concern that a specific variable is to some degree a proxy for the value that we really want to publish or have agreed to publish. And other aspects that occur, of course, are that we have different temporal dimensions than needed, the uncertainty levels of the data that have been measured or the quality aspects of the data have been measured may differ, and the demands of the quality, so how precise the data should be, may be different than from your target statistic. So a key aspect is the integration of the different spatial data sets that we have. And I put up a matrix, and I hope that the matrix we are using here is a key element in understanding what kind of transformations are needed. We can disaggregate into different sorts of geographical information. So the ones we distinguish here are information that are based on points. So measuring stations, for instance, could be considered as a point-based information source. We have information on grids or raster cell information, so Earth observation data can be considered as raster data, but also as statisticians we also produce the grid statistics on all kinds of information, polygon information, and network information. So network information is something like the road network or the water network, or maybe even consider people knowing each other as a network, but we'll not go into that here. Most often in this context we use the route, the road, or the public transport network, for instance. So we have different kinds of informations that spatial informations that we want to integrate. And for the integration we need different methods. And these methods, they rely on assumptions, for instance, about the level of homogeneity of the data sources that we have. So if we transpose or transform or project some polygon onto another polygon, we will see some parts falling off or falling out. And if we use some kind of methods to, like, for instance, standard areal weighting, where you just take the proportion of the area that overlaps, then you assume that the entire area is completely homogeneous so that you can interpolate the data without any loss of the quality. Those assumptions are important. So typical assumptions that we consider are, I already mentioned the homogeneity or the level of heterogeneity that we're working with. For instance, we assume that the yield within a field is always the same no matter where you look in the field. The representativity of the data that we've collected, so is, for instance, like the measuring stations of air quality, are they sampled on the right places, like we as statisticians expect? Proxy validity, so maybe we use NDVI as a proxy for biomass, but is it a valid proxy for this type of information? And the temporal stability, so if we measure, for instance, every year, we more or less expect that the value will not change within the year, and only next year, by some magic proceedings, the value will have changed. So we expect some temporal stability as well. So to summarize these assumptions, they are applied on the geometry of the data that we measure. They apply to the timing, so the temporal aspects of the data, the proxy validity, and the scale. So if you zoom in or zoom out and you do some reprojections, we expect that the patterns will remain valid after aggregation and disaggregation. And of course, we know that this will not always hold up. So it's very important to check for these assumptions. So very briefly, I will mention some of the methods that exist for transformation. So for aggregation to different supports, so from a polygon to a raster, for instance, we can use areal weighting or decimetric methods in which you use an auxiliary variable. For spatial interpolation, we can use Kriging, spatial smoothing techniques. The proxies can rely on regression or machine learning and deep learning. We've seen many examples of those here. One that has not been mentioned often, but could be also important, is that if you have information on a certain extent and you're reprojecting data from another extent, that you want to preserve the totals in some way. So that could also make use of information, of methods like benchmarking. And for sparse observation, my colleagues from the methodology department, they are always very enthusiastic about these types of methods, are about small area estimators, where a model kicks in when the observations are sparse and is built upon the data itself when the data is abundantly available. With the information we had, so we've been discussing specifically forestry, biodiversity, agriculture, of course, but we think the integration problem will appear in many different domains. So I took some examples here for the use of gridded statistics, when you want to apply them to polygons, for instance, for the city municipality, measuring number of containers on the harbor, using a network graph to estimate the traffic density, or combining it with air quality, for instance. So the point is that we think that the integration problems that we see are generic over the different sources of the different applications of spatial data that we use as statisticians. Coming back to the statistical part, so as a statistician, and I think we heard it also already in the other workshops that I took part in, it's very important to have a clear picture of what we exactly want to measure, and also a clear picture about the spatial and temporal support that we want to measure, and specifically look at those constraints to see if we can find the variables that match those targets. We also must use explicit assumptions about the things I mentioned earlier, like the homogeneity and the representativity of the data that we have, or the lack of representativity. So it's very important as a statistician to be aware of the assumptions that we make when using those data sources. Validation strategy, it's been mentioned also before. We are able to build beautiful models that do predict some kind of indicator, but it's also an equally important to try to validate the data that comes out of the model with other data sources. So corroboration of the data that we have really is a key aspect of the work that we're doing. And one that's also, my colleagues also keep mentioning it to me, it's very important as a statistician to communicate that we are not certain of an exact value. We are more or less certain about a range of values, and that's about it. We cannot know the entire truth, because then we would need to measure everything. So all our statistics come with a level of uncertainty, and it is important that as we will be starting to use Earth observation data sources, that we know something about how we derived values from those Earth observation data sets, and if we can assign a measure of uncertainty about those values. So today, we've put up a great number of boards. I'm not sure about how many groups we will have, but what we will be doing is 8 groups. Great. What we will be doing today is, based on different cases, discuss the different aspects, the spatial characteristics of the data sources and the target statistics. And we're going to ask from you to identify the key transformations that are needed to transform the data that we have, so the different data sources that have been mentioned per case. And if you can think of other data sources that could be helpful, then please put them also on the wall. But the key aspect is identify then the transformations that are needed to go from one spatial support, so like point data, polygon data, to the target polygon support. Then in the next step, you do the transformation, but as we said, assumptions are important. So we have to know about what assumptions we make when we do the transformation from one extent to another. After you've done that, and it will be quite a challenge, but we will try to help you along the way, also think about the ways to validate the data that comes out of the transformations, and also think about what is still missing. So are there any data sources that are needed, or other data sets that can be used to corroborate the data, something that is needed for the statisticians to know so that they can communicate certain quality aspects. So that's the key of what we're asking of you today. On each board, there will also be a case template describing every step in detail. So we are asking a lot of you, and I know it's the last day and it's the last session and everybody wants to go home, but really ask from you that try to be as free as possible with your ideas and see if you can come up. And we have the advantage that we have been through two full days of exposure to all kinds of examples. So please use that information and try to put it integrate it into the board. So that was my last slide. I can show you one case example, but I think I'm already done with time. Okay, Remco says that I can proceed. So one case, the typical example, we've seen it many times, would be on crop type statistics, and we want to know the distribution of crop types at the NUTS2 level. And we know we can use the spectral fingerprint or the radar fingerprint of the different crops to do an estimate of certain types of crops. But we need other data sets to integrate with the Earth observation data. So maybe we need the LPIS data and the polygons from those data. So what we ask from you is do a data description of the data that is put on this for this specific case. So in this case, describe the LPIS administrative data, so describe that as a polygon, but also mention that it may contain several subparcels, or that it is owned by different farmers, or, well, different quality aspects that put strain on the assumptions that you have as a statistician. Then for the transformations, like going from the LPIS parcels to the EO, the Earth observation raster, how do we select the raster cells that are within or on or outside of the polygon? So are we using the parcel boundaries, or are we using the pixels? Things like that. So try to find the transformations that are needed. As a next step, and I think hopefully in the discussion you already have been discussing that there are some problems with the transformation, or some problems with the assumptions, to try to evaluate how this risk is defined and how you can, identification of the risk is the most important part. And then diagnose the risk and try to identify what kind of data source or what kind of methods could help in doing this type of transformation while keeping sure that the assumptions are being met. And as a last step, try to think of ways that identify or validate the data sets that comes out of the actual estimates. So that's the exercise for today. I hope that it will be clear and will work out. And with that, I give it back to Remco.
Thank you, Marco. One more comment on the flips. Step 3 combines actually step 3, 4, and 5. So not that you are confused. If correct, you all received a post-it with your group number. Some of you probably came in later, don't have a post-it, so Zach is standing there. Maybe he still has some post-it. Then get a number with Zach. I would like you to ask to go to your group and of course have first look at the case. So read the case together and then start the discussion. You have a lot of time, so it's about 40 minutes. So take your time and Marco, Ivana, Zach and Anatol will walk around and will help you. So please go to your group and yeah, let's start. Oh, sorry, that's a good one. This is number 1, that's number 2, 3, 4, 5, all the way back and right, 6, 7, and 8. Thanks for asking. Okay, we have 2 more minutes. So please slowly close your session. Okay, let's finish up. And if you can put your card in the matrix, that would be lovely. Marco? Ja. Eentje? Iedereen, maar dat... Ivana. Ze komen dadelijk hier naartoe lopen en dan kun je ze stikken. Marco gaat zuiden. Okay. Yeah, almost done. Yeah. Kunt u gewoon blijven staan? Net zoals de hoofdje. Oh, zo. Ik was erin. Ah, oké. Goed zo. Sorry. Oké. Ja, je hoeft nog niet te foto's, hoeft nog niet. Kijk eens uit. Sorry. Sorry. Oké? Ja, is goed. Dank je. Ja. Oh, so, no problem. 2, which one do you have? 5. So 2 and 4 are missing. Where is group 2? Okay, group 2 and group 4. Okay, 2 more groups and then we can wrap up. 2 and 4. But they're riding. Okay, in the meantime, while 2 and 4 are still finishing up, we have a question here. And the question is a so-called is so-called thermometer. And the question is further research to develop validated methods is valuable and required to produce high-quality Earth observation data statistics. If you fully agree with that sentence, you put the sticker very high, and if you say rubbish, you put it very low, and anything in between. So what you will get is when you come here, it's like in the Catholic Church when you get the hostie. So two people will standing here and will give you a green dot, and if you can put your green dot somewhere on this thermometer. Yeah? Let's go. Marco? The first row also always gets a special treatment. Okay. Just yeah. That it is important to develop validated again. Data are perfect. No, it's about the transformations. Validated transformation. Yeah. So the done yet the workshop, right? Yes. It's about the workshop. Yes, the transformation. Yeah. Thank you. Okay. Marco. Ja, ik ga vragen mensen wat toelichten. Wil jij eerst deze toelichten? Oké. Deze.
All right. I'm going to try to make a summary of what we all did today. So we walked past the boards and listened into the discussions, and I think they were all very good and interesting discussions. You were really into the topic, so thank you for your contribution on that. And in the end, we asked you to identify what kind of transformation is actually the key aspect of the target that we wanted to find out. And I realize, we realize that's a somewhat maybe artificial construct to put it onto only on the transformation, because other problems will be there as well, of course, so the modeling, the nomenclature, and other aspects. But still, we're here with the key aspects of the transformation, and if we look where the specific problems will be arising, it will not be on network data, and that's understandable because using network data is really a niche thing. But we see that it clusters around the grid, raster, and polygon aspect, and also as a source sometimes from the point to grid and raster. And what we see is that that our research efforts really should focus on how to interpolate or use point information to estimate a bigger extent, or how to go from a grid to the point, and also other types of disaggregation or aggregation of the information to the target extent. So I think we'll be making a photo, of course, of all the boards, and this will be some sort of indication of where our research could be pointing next. So thank you all for your contribution.
Thank you, Marco. We also had this question. Is there anybody who wants to clarify why he put his dot high or low? Okay. Marco, can you make notes?
Maybe just a comment to the question. I was a bit Earth observation data based is a little bit my problem. I would say Earth observation supported, yes. So therefore I wasn't quite sure where to put it and put it maybe a bit lower. But if it was supported, I would say yes, for sure.
So now you put it a little bit in the middle low, but because it's not, instead of EU based, you would like EU support.
Yes, because
okay,
I think
thank you.
Not basing it on it is dangerous, but supporting it with Earth observation is great.
Thank you. Any other, any other comments or would like to clarify where you put your dot? Anyone? Going once, going twice. Then, thank you. Yes. Because Marco is going to do a PhD in this kind of stuff, if you think, hey, that's interesting, and you would like to be involved, or you would like to be informed, that's also a possibility, please write down your name and your mail address, and then Marco will stay in touch with you. Having said that, once more, thank you for your contribution to the workshop. I had a lot of fun, so thank you. And a big applaud for Marco, for Ivana, for Zach, for Anatol for their support. And of course, of course, also for yourself. Sorry, I forgot the most important persons. So thank you. And have a good trip home. So, thank you.
Hello, good afternoon. We are about to start with the workshop wrap-up session. So it will be a sequence of a few highlights from the different workshops. We have 9 in total, so I would kindly ask you to be very short to the workshop organizers with your highlights, maximum 2-3 minutes, so that also all the other participants are made aware of the key conclusions that you discussed. So we are going to start with just a quick recap of the first workshop for whom was not present the first day. And so I'd like to give the floor to Mark.
So I'll be very fast on this one, because when I did the wrap-up the first day, I only talked about in-situ data. So in the meantime, the group that organized, this fancy way of exchanging, well, in a silent mode, ideas, did some sort of grouping. So, of course, it's not yet the final versions, but again, of course, we put ground truth and in-situ data quality at the very first topic on which we need to work. And here you see, of course, the ideas that I'm not going to read them for questions of time, but you see them. The second one, and you will see actually that in some ways related as well to the previous one, because you see, for example, incentivize in-situ data sharing. But the idea here is about data standards and sharing and alignment between Earth observation and statistics. So that's the current grouping we've been doing, but probably we'll do better in the future. You have to understand that this is done a bit in a rush. So we've tried to put the ideas in that goes into that idea. And then there's a lot of points that are related to governance, to coordination, to political will, and we know that this is really a key point. If we don't get organized well between us, of course, we'll go nowhere. So things need. I don't know if I have to look at one in particular. For example, having an overarching entity doing the job of coordination and implementation. Okay, that's of course a very challenged one. Because we have multiple actors, but you understand that anyway, we need to look at the whole governance systems in order to enable the uptake of Earth observations in statistics. Skills trainings and capacity building, it's key. That's also why we had workshops on that topics, and it came out during the first day. And I don't know if I have everything. And of course, funding and resource mobilization, because without any money, it's not that we can do much. And communication advocacy is, of course, a very important part of the work we need to do together. And I stop here, Federica, for the...
Thank you, Mark. So we move to the next workshop. So starting from today, 10 a.m., I would like to call on stage Ludwig for providing a wrap-up of the workshop on accessibility, data infrastructure, and interoperability. Thank you, Ludwig.
Okay, we were workshop 4, where we were exploring in this room accessibility, data infrastructure, and interoperability for the purpose of NSIs or NSOs adopting Earth observation methodologies into their workflows. So the primary question that we want to answer is how might we make Earth observation data infrastructure more accessible and interoperable so that statistical offices can adopt it as routine part of their production. And it started off with 2 presentations just to set the scene and give some examples to foster the discussion. And it was by William Ray describing and visualizing what CDSE looks like and what it offers. And then Hannes Reuter from Eurostat was giving some examples on how they have moved some of their processing on Earth observation to the CDSE and how they use it for generating data for their work. And then we had an exercise kind of mimicking the end of a sailboat exercise, just like was described just now. And here we had defined 9 challenges as themed stations, so every station had one theme, and then each participant was moving around in 3 different stations, and then ended with a voting. And the 3 stations, I will go through the 9 stations and their themes, and then the kind of highest voted proposal to solve the challenges. So the first one was the adoption challenges, and here it was identified that making visualization products easier for non-experts, kind of the people who are not at all used to Earth observation data or maybe spatial data at all, and to make these very, very easy to read. And then on the second one, statistical production, to clearly quantify Earth observation uncertainty, spatially and temporarily explicit. On the third station, it was on discoverability, and here it was identified that more use cases and also providing more cross-knowledge sharing with lessons learned. So that is maybe something for the Earth observation community to meet and try to describe what is actually possible. And then on the fourth station, we had the Earth observation skills gap. And here it was identified that more workshops and training for statistical experts would be beneficial, and also to guide on where to start, because of course Earth observation field is quite vast, and maybe it's hard to understand where to enter. Then on data privacy is an important one, and here it was identified to ensure private data space that it's secure and that it fits to the statistical office's policy. On the political will, it was to demonstrate the ease of obtaining analysis-ready data and also show on its maturity. So that what it means is to kind of show higher management on the possibilities and how mature some workflows are to be implemented already. And then a bit more on the technical, on IT infrastructure, guarantee that these systems have a long-term processing capabilities, not just for a few years, so the longevity of the planning. And then on tools and interfaces, it was requested to have tools to integrate existing workflows into the CDSE, so existing workflows as is employed by statistical offices. And then the last one, missing information products. And here it was identified to systematic use of Earth observation to identify enumeration areas for household surveys. Also to be able to...
Peng Yu Hao.
Thank you. Just have a very brief summary of what I have discussed in the workshop. Our workshop have divided into 2 parts, and the first part is several invited talks from several team leaders about their application of Earth observation for the statistical work. Basically, we have introduced the remote sensing data product portal. We have developed to federate all the satellite observation products created by FAO or used by FAO member countries together, and how it serves to our users. And following, we talk about the FAO-Stat and several data sets available from FAO-Stat. And then is AquaStat, which is agricultural water management platform for drought monitor and agriculture water productivities. And followed by all these invited talks, we have a panel discussion on how the Earth observation could contribute to the improvement of the statistic. So we have some conclusions. As the first is that we should integrate the Earth observation with the ground surface statistic together to improve the existing statistic collected by the focal points from countries. And there is suggestion from the participants from VITOS that it's better that in FAO we moderate all the different data platforms together and make the data standardizations. In this case, we could better service our users. And there is another question raised by participants that currently we have a lot of dashboard, a lot of platforms, and even the number of platforms is more than the number of users. So in that case, there is a proposal that AI could in the future better bridge the gap between the data and the users. So in this case, we should better focus on the data quality to verify that the data we are using is reliable. In that case, we should have more focus on data itself rather than developing too much dashboards. That's it. Thank you.
Thank you. Indeed, quite striking outcomes from this workshop. Thank you. So we move now to the workshop on reference data as a backbone for EU-based environmental statistics. So it's you, Hannes.
Thank you. Good afternoon, everybody. So quick wrap-up from our workshop. We had 3 back-to-back scene-setting presentations from Eurostat, EEA, and GRC. And then we had a group exercise, and we had 4 questions prepared and asked colleagues in a group exercise with silent and vocal expressions to come up with something. So first question which we had was, what data sets are missing from in situ at EU level or at national level? And we have 2 clear winners. The national forest inventories need to be available at the EU level, as well as the IX data availability at the EU level. We know that they are available at the national level, but they need to be aggregated, work together there. That was our first question. Next question was, which agreements or governance model needs to be in place to get required data sets? The outcome out of that one was that we want to have a federation of reference data repositories. You will see it also in the next question. And that we need to enforce the sharing and the monitoring of public funded data in our organizations, as well in the whole in public space, because we see that still sometimes we have people sitting on the data and they do not share. This is an outcome out of that one. I think it's quite striking, something to do. And the next question was, do we need a single federated data repository for reference data at national EU level? Sorry, I mean, that's maybe a self-intrinsic question. Yes, we do. Yes, and then we need to guarantee fast and easy access to users at all levels. And then we need to also ensure that we work on the respective harmonization and comparability of the data. Last but not least, we focused on in situ requirements for the statistical data processing. Keep in mind, we always, oh sorry, I'm over my 2 minutes. Apologies, Federica. So let me just wrap up that one here. This has a dimension because we are in the space-time data cube. It has a temporal dimension, spatial dimension, semantic as well, the usual governance questions and how do we get the data as well. Out of the vote, there were several clusters there. We need that the temporal aspect needs to be of the in situ data collected and needed needs to be more respected. And we need to really get it in our mind that temporal aspect is needed. For example, in soil science data, sometimes we have soil samples and we don't know from which, maybe we know from which century it's coming, but I mean, this is what really. And then related to that one, if we talk about temporal, we need to have protocols for people collecting in situ data. So, you know, that space and time is really defined as well. With that one, thank you very much. Grateful for the workshop and for all the works we have done here. Thank you.
Thanks so much, Hannes. Very clear and concrete outcomes from this workshop. Now it's the turn of capacity building with Zacharias. Thank you. The floor is yours.
Hello. This workshop was facilitated by my colleague Carla Martins, and we want to thank also Remco Paulussen for co-facilitating with us from Statistics Netherlands, also Nina Hoffer from Statistics Austria. The structure of the workshop was to split the participants into people from the NSIs, people from international organizations, from academia, from businesses, and although we had a few number of participants, there weren't so many, they were well represented, all of these categories. So first we asked them for an honest take to assess their capabilities in a number of fields. One of those was the data sources. And then we mixed these groups to try to find out how we can see if one group of people have a good capability in an area and another have a lower capability, how we can bring them together, how we can find synergies and alignments. So the outcomes of this exercise is that on the data sources side, on satellite, orthoimagery, and Copernicus services, the NSIs rely heavily on the expertise of the international organizations, of academia and the public sector in general, and existing structures such as the UNGGIM, GISCO, and the EO for Statistics Task Force can be leveraged to assist. Also, there is a momentum here with this conference, and there is a recognized need to maintain it through continuous meetings, and the capacity comes from the people, and exchanging capacity means maintaining good relationships on the personal and on the business level. So we would like to take this opportunity to thank again the organizing committee and especially Federica for all the job she did, and we hope also that she's not too tired to think about the next EU for Statistics conference. And also, we would like to inform everyone that CROSS is a public platform that's hosted by Eurostat for sharing resources and events and links, anything related to Earth observation and capacity building, and we encourage you, and we decided to actively pursue using it more. So on the different statistical domains, what we could do better to encourage capacity building is to include NSIs in the existing collaboration between business and academia. And we also identified the need to improve knowledge sharing within the NSIs and between different member states NSIs. And also, a point was the engagement of different public sector agencies, such as environment, forest agencies, and there isn't a one-size-fits-all solution to engage them in Earth observation. So what we could do is to encourage collaboration through grants that are not very narrow in focus and include many countries. And finally, for the research and methodological capability, mutually beneficial relationships should be fostered between the business and the NSIs with clear profit incentives for the businesses. And on the business side, they must provide clear requirements and investigate and accept the NSI methodologies for the validation of Earth observation products. And we acknowledge that AI and machine learning methodologies are still developing, and that basic ML methods linked to your activities and NSIs could benefit with engagement with the business sector. And finally, statistical excerpts emphasize validation as a key area where NSIs can add value. So, thank you.
Thanks so much, Zach, for the comprehensive set of recommendations, very clear. And we hope that StatEO could be a moment for maintaining this momentum of collaboration and perhaps also in the future. Thank you. So now we go to the other more thematic kind of workshop on forests. So I would like to call on stage Natalia for the workshop on GFY R&D session on integrating Earth observation and ground data for enhanced forest-related biomass estimation. The floor is yours.
Thank you. So within the GFOI, which is the Global Forest Observation Initiative, the last plenary that took place last year, we had a very rich discussion with different end users, including countries and agencies and academia. We picked up what are the major topics that needed kind of like attention in the next coming years, and we had identified 3 urgent topics that need, a bit of a few recommendations. So we decided, that's what inspired this workshop, and we decided to split into 3 groups. One related with how Earth observation probes can actually be used to design new field service and new ground reference data collection. The second topic related with what are the best techniques to harmonize Earth observation probes with national forest inventory data. And the third topic related on how can we integrate Earth observation probes with national forest inventory data to enhance our estimates and inference of the data. And many of the topics that we discussed kind of resonated with the previous workshops as well, but I would like to highlight just a few. So for each of these 3 topics, we split into 3 guiding questions. One related with what are the opportunities or where we see like most potential, what are the remaining challenges, but also finally, what are the future perspectives in the, let's say, short term, in the next couple of years, and where we should prioritize our attention. So in general, in terms of opportunities, I would say, of course, observation probes can enhance the spatial and temporal coverage of many analyses that we do. We can enhance the precision of our estimates, which means, for instance, in terms of sampling campaigns, that we can reduce, be more efficient on the budget as well, which is a tremendous advantage. In terms of the challenges, actually some interesting ideas came up that not only, like for instance, that we have plenty. There's the perspective that we have also already like a bunch of products available, but sometimes we need to understand how to use them best. So guidance and recommendation is a general thing that needs attention on how to best communicate the limitations and the opportunities of the products that are available and the uncertainties associated with them. And challenges related with the harmonization of these data sets and the availability of both data sets also from the ground, but also taking into consideration, as was already mentioned, the data protection considerations. So for future perspectives, as I said, guidance and recommendations is for these different topics is a priority. Accessibility to the data. We discussed even like having some kind of libraries and platforms where we could like allocate both of the data sets if we have like concerns on the data privacy of especially national forest inventories. But one of the key takeaways that I would like to highlight is that we discuss much how like there's a need to have synergies between the communities, between the Earth observation community and, for instance, also the community doing the statistics and the field-based inventories, and how we need more spaces like this to interact and understand how to move forward. And I guess that potential iterations of such conference would be an ideal platform as well.
Thank you very much, Natalia. So we now are almost approaching the end of this wrap-up. We still have the workshop from pixel to statistics, working towards validated EO and in-situ data integration practices. Welcome. The floor is yours.
Thank you very much. This workshop was given by my colleagues, Marco Roos and Remco Paulussen, who sadly had to go to the airport already, so I'll do a little wrap-up for you. This workshop was really focused on the integration of both Earth observation data and all the other amounts of data that we could use. So think about registry data, points, at any kind of resolution. And we had 8 different cases on which our tired but still quite excited and creative participants could work on. And they came up with solutions for these different cases and how to integrate the different data sources for different statistics. I would highly encourage you to look at all of the boards and see what they came up with. But overall, the biggest thing was that a transformation between a custom polygon and the Earth observation pixel or the registry points were the biggest transformation that we should be working on. Thank you very much.
Thank you. So we now move to the standardization and quality of EO in statistical processes with Carla. The floor is yours.
Thank you, Francesca. So this workshop was about how to standardize the procedures of Earth observation into statistics, into the statistical process. And we divided this workshop into 2 questions on how can we include quality documentation in data, and the other one was on how to cooperate within the institutions. And I'm here with my Post-its, the ones that were most voted, and we got to the following conclusions. For quality documentation and data, we need to standardize the documentation protocol, meaning the metadata, and this we need to do by statistical domain. And this includes the ATBDs, the product user manual, the quality control guide. All of this has to be standardized so that statistics, the users, we're all on the same page and we all understand what we're talking about. The other proposal was to introduce into the tender specifications of the Earth observation products the need to publish the code. So we want it to be fair. And for the second question on institutional cooperation, there were 2 most voted. Horizon Europe, ESA, to develop series last-mile applications for national statistical institutes, together with Copernicus services for continuity. And the other one is for ESA, JRC, EEA, and Aerostat to jointly work on a number of pilot activities that define what is needed to have certified end-to-end production of Earth observation-informed statistics over the whole value chain. So pilots where we would do the whole thing, everyone would be involved, and then we would have the model to be applied. And that's it for my workshop. Thank you very much.
Thank you so much, Carla. Very clear recommendations. It's also delving into very technical details, and also thanks for recommendations to ESA and partners. So we have now the final workshop, report on trust and uncertainty.
So, okay, I'll take it from here. We want first to show you how the workshop is being organized. So this was the introductory talk that we gave to the participant. And the quick questions, of course, there is no doubt that trust is a fundamental condition for the uptake of observations in official statistics. So the key questions we asked the participants was what factors build trust in Earth observation data or erode trust in Earth observation, so in both ways, when used in official statistics. And for this, as an output, we wanted to have practical approach to ensure that the products are not only scientifically robust, but also trusted, accepted, and used by the statistical community. So that's what we wanted to get. So we follow a bit the same logic with the with the sailing metaphor, but we only worked on the wind and the anchors, and then we went into an ideation, so into finding solutions in order to address the key challenges. What was important, I don't know, it was the alignment with the principles of official statistics. So we did it first looking at the fundamental, and that's very important for the Earth observation community. You need to look at how the statistical community is working. So starting with the UN fundamental principles, there are 10 of them. And so what we try to do in the introductions is try to translate this into what it means for Earth observations. For example, on relevance, do Earth observation derived statistics meet user needs and are they unbiased? And so on. We did for a few other ones like transparency, misuse, and so on. And also the code of practices of European statistics. So here we give to the participants the key words that they have to keep in mind, like objectivity, sound methodology, timeliness, comparability, reliability, accessibility, no excessive burden. And so these are really what is requested from a European perspective for the productions of official statistics. And that was the key point. It's looking at the whole value chain. And so we presented that slide showing that at the end, especially when we talk about uncertainties, there are uncertainties coming from each of the steps. So starting from us, the space agencies, and the data we provide that are obviously some inherent uncertainties to the product, moving into the Copernicus services and the value-adding industry, so coming into Earth observation products, then moving into indicators, and at the end of national statistics. Along the whole value chain, of course, the key actors are different. Right? It could be the space agency at the start, the value-adding industry in the middle, and then the National Statistical Institutes and the other national agencies. Obviously, in practical terms, it can be very different. I mean, there are statistical institutes that start from the Sentinel data and not from high-level products. And then we put, of course, the key points that we had to address: uncertainty, metadata, fair principles, transparency, reproducibility. As an outcome, maybe while I'm giving you the key, sorry, I need always to get it. I hope that, yeah. Well, I'll give you what were the key, what do we call it?
The how might we, so, is it on? Yeah. So we, maybe I just, 30 seconds on how we did it. Yes, that's okay. Can I have the blue?
Oh, sorry.
Yeah. So,
but we need to show the slides. Okay.
Yeah, so what we did is what we did was then similar to the workshop number 1. Most of you have been there, and the results are always still on the walls. So we did something similar with a sailboard here. We were 5 groups and we were quite productive. And in the end, we reformulated these to how might we questions, which are here on top. We don't want you to read them, so this is why Mark wanted to read them for you. But just see how many first ideas we gathered as starting points for the next the next endeavors. So
yeah, I will read them, but I will read them the yellow stickers. So the questions and what you have in the orange stickers is actually how we should address this and providing a solution and something that we need to do it, and we will do it. So the first one is collect sufficient standardized and spatially spread ground truths. We go back always to this, and create a platform to share data with FAIR principle. The second group came with ensure that uncertainty is known and findable for all regions of the EO products and through the whole value chain, and transfer uncertainty maps into official statistics. It's not an obvious thing. It's something that is common from the EO perspective, but not really in the statistics world. The fourth one is produce uncertainty, again, levels with enough confidence to insert Earth observation in statistics workflow. Then the last before one, find a way to support the accessibility of the in-situ data, reducing duplicity of resources and cost effectiveness. And the last one, get clear common specs on how Earth observation data products have been produced.
Thank you.
So we now transition to the final session. It's not a session, it's just a few minutes of key highlights from the participants and the partner organizations. So I would like to invite on stage all the organizations that supported us in making StatEO a reality for just a few key takeaways.
So I will share this last session, so it shouldn't take too much time, so I hope that most of you can still stay in the room. And the first thing is to put the group photo. So you will all receive a copy. So I'm sure that everybody is trying to find where he is in the photo. So we've reached the end of the conference. So over the past days, we've had a very dense, I guess you notice, a very dense program. I mean, full of plenary sessions, oral sessions, poster sessions, workshops, and on demonstrations. We hope that you find this mixed format of the conference appropriate for engaging the dialogue between our community, because that was also what the purpose of all of this, and it didn't provide to all of you plenty of opportunity for discussions, even if there was a lot of silent workshops, but I'm sure they managed to communicate through post-its. And we would like, of course, to thank the organization from the organizing committee. They all play a really key role, I must say, in shaping the conference and contributing to its success. So let me now invite each of them to say a few words, 1 or 2 minutes maximum. So Federica first, for ISA.
Thank you, Mark. So it's a wrap. So I really hope you enjoyed the process. You had a productive past 3 days, but also that you enjoyed it. So if you had fun, raise your hand. Nice. Woo. Very good. So this is really, for me, was really a milestone event for all of us, I think. And first time that we really tried to bring together these different communities and watching these different realities to converge here in Esrin has been really inspiring. So what has been really striking was the diversity of the perspectives. So we had many different kind of backgrounds. So we had national statistical institutes, we have international organizations, academia, the private sectors. So this all really helped to have and gather a better understanding of the different journeys, of the different challenges that each of us is facing. So, but this is really indeed important to bring this forward. And it's also clear to me that this convergence is just possible, only possible if all of us collaborate. And this is what we are seeing. So I think we all share this strategic priority of bridging these two different realities. So given this common interest, I think what we need to do now is to bring this to action. So we will, of course, act on recommendations, on all the recommendations we received. And for me, one of the key takeaways personally was the need to ensure that we have a more structured flow of information from across the whole value chain. So really starting from the sensor acquisitions to the statistics-ready products and up to the aggregated statistics. So we acknowledge that this is only possible with collaboration across the different worlds, so that we are not working in silos. And I think this conference is really a step forward in this direction. So I'm really pleased to see how we are all committed with working together towards this common objective. So I would like just to thank you all for all of your contributions, your energy, and for making StatEO a success. Thank you so much.
No? Yes? Okay. So the next person I will invite on stage is, of course, Marta. Yours that was so committed in this conference that...
Okay. Thank you very much for this welcome. I would like to give one key message with a few sub-points. Keep the momentum. Use profit from these activities. What are the, and I would like to mention 5 sub-points. One is the Earth observation and statistics communities need to stay connected at European and national level and should contribute and should continue discussing. Second, we have seen that we need more communication on requirements, challenges, and outcomes. So look for occasion and keep the communication running. Number 3, everyone can profit from collaboration, you have mentioned also. So we should keep the momentum and build up even more closer collaboration. Number 4, build upon the outcomes. I am electrified. Yeah, if I just be. Okay. Yeah? Can you hear me? Yes, perfect, thank you. The number 4, build upon the outcome, inclusive of the workshop. So we are looking forward to get the documentation from you and this help. And 5, to achieve all of these expectations and what we outlined, we need resources. And that we have to communicate also in different means. And my last point is I would like to thank the organizers, especially Federica, Mark, and the team here in ESA, but also the co-organizer teams and also my colleagues who were extremely excited and heavily involved in this. Thank you, and looking forward for a good collaboration and continuation.
Yeah, you should stop speaking, sorry. No, I'll keep it short. Thanks for staying here, all of you, the diehards, staying until the last minutes. So that already deserves an applause for you. But this was a very interesting workshop. From DEFI's point of view and from Copernicus' point of view, we have a lot of homework. We take it seriously, because we prepare for the next MFF so we can take all this into account. I take it seriously myself because I will be closely involved and I will make sure that as much as possible of these things are fed into the process for a new Copernicus program. And the only thing I wanted to add is we are here as Copernicus to provide you all these nice things, but we need you to support us as well. So every time you can support Copernicus via your national administration, via whatever outreach, please tell the people that Copernicus is important and that we have to keep to get this funding, because it's not about a few euros, it's a big budget and a big battle to keep it. Thank you.
Oh, sorry. Then Sue for the European Environmental Agency.
Oops. That's it. That's when you step with an attitude. Thank you very much. Well, first I wanted to congratulate you for the organization. I think the conversations we've had show that it was really needed. So that's great that you had the initiative. So following on the words by DEFIS, what I think that the two take-home messages, well, actually 3, that I get is, one, I heard it someone, and this was this person, in one of the workshops, yes, you, one of the workshops that I attended today, and it's to put the users in the center. So when we discuss these things, to change the view from the producer to the user perspective, and I think that would probably help bridge the gap in the language that both parts are speaking. Second, of course, as a EEA representative in situ, which is needed and it's key, and we have already said it several times that without in situ, CLMS will also not evolve. And the third part is on increasing this policy relevance, but also making this taking this final step towards the last mile applications. And with this, thank you very much, and thank you for the opportunity.
Thank you, Soraya. Ludwig, do you want to add something? No, it's just because I see you on stage, so I
can be short. I don't have much to add. It's many good points given already, but all I can say is what I presented on the first day. I think the challenges that we are faced with and tasked with to support the monitoring and so on for policies, I think the collaboration between the two communities, the Earth observation and statistical, is very important. And I think I really like what was in the workshop here today, or the conclusion of it, that the statistical community kind of tasks Eurostat, EEA, and so on with what they need to get into the space of using Earth observation and so on. So I think we will take that home, and I hope we can keep this channel up that has kind of opened up here today, or these 3 days. So I look forward to that.
Thanks so much. Thanks so much, Ludwig. So then we had Mark Dowell on our list, but unfortunately he had to leave. I know that a lot of you will be rushing to the airport. So Michael from OECD.
First of all, thank you so much for the organizing. Oh, there we go again. Yes. Thank you so much for the organization, Federica. Special thanks to you. Your dedication and leadership as well, I really appreciate it. And I learned a lot as well from all of the colleagues and seeing you all operate and how you do. I wanted to say quite a few points, but I'm going to trim it down a bit. But something I really saw is that there's so much being covered in this conference, from biodiversity indicators, air quality emissions, policy relevant indicators, how they link to SDGs, KM, GPF, national and EU policies. I think this is really interesting, all those interconnections, and I think this conference is really worthwhile keeping and deserves continuation. So I really do hope personally that's the case, and that I can, have more of my colleagues join me next time. I also feel like there's a strong sense of collaboration and willingness to collaborate, and I think we can definitely strengthen that. And I think I don't speak just for myself, that I think a lot of people have been able to talk to so many people in these last 3 days. And I know I will be following up with so many people to talk about different topics. So I hope that's also the same for you in the coming months and years. I did want to highlight also some challenges I see in front of us. One is that there's this rapid growth in Earth observation data, and geospatial data availability and quality is very positive. But statistics aren't always policy relevant, and we require really better integration, I think, with non-EU data sources as well. So I think we need to move from data availability to decision-ready information, and that's something we need to keep working on, I think. And that's it for me. Thank you so much for the whole conference and the organization.
Thanks so much, Michael. Then Stephen. Stephen is representing, of course, UNSD, UN Statistical Division, or UN Stat.
Thanks very much. So my colleague from the Netherlands said something quite amusing. From the statistics community, we make tables and we put them in a book. And essentially these tables turn data and information into evidence for decision making. So the value chain we were talking about in day one. And I think over the last 3 days, we've heard a lot about how the data quality assurance frameworks, the principles, concepts, and classifications can help build trust in EO data for decision making, but it can also provide clear targets for EO data providers to actually get their data into the central information system of government. At the same time, we've seen some really exciting responses from the EO data community in terms of responding to meet those targets, both in terms of the data, but the critical platforms to help integrate that data and hit the phenomena that we're particularly interested in. So a great many thanks to Federica, Mark, ESA colleagues, and all of you here for coming together and to create this opportunity to have these discussions. I'm really looking forward to some outcomes for the workshop and really understanding how the Earth observation and official statistics communities can combine forces and get the information that we need to policymakers, planners, and other decision makers so they can make better decisions, better evidence-based decisions that can really help us deliver on our shared aspirations for sustainable development and better outcomes for people and nature. So thank you very much.
Yeah, thanks so much, Stephen. So now we move to the UN Economic Commissions for Europe, so with Taiki.
Yeah, a lot was already said, so I try not to repeat. Yeah, so of course one big takeaway, or not takeaway, we knew it already, of course, but like statistical information enriches geospatial data, and geospatial data enriches statistical data, and it's not in an additive way, but in a multiplicative way. So that's very important. So the use case is very clear, but despite that, we still have a bit the issue, although we have very good examples here during this conference, but there's still a bit an issue that the communities are not so well collaborating and integrated. So I think that is a bigger challenge. You can see it from the participation here. I think 10% is from official statistics, even though it is about official statistics NEO. And with the last EFGS conference we had, it was the reverse. So that's still a big challenge. So we have common frameworks, we have standards for integrating these data sources that all exist. And of course we have technical issues, methodological issues, metadata, discrepancies, et cetera, but I think if we overcome the challenge of bringing the communities together, those will be resolved easily because we're all motivated and that's what we love to do. But getting the communities collaborate more, that is, I think, the biggest challenge. And that leads then to the final takeaway, which is probably the main and most important conclusion, is that these type of events are hugely useful. So it brings together the communities, it brings understanding amongst each other's differences and similarities, and especially these interactive activities also, they bring a personal touch to it, they bring people really talking to each other and getting understanding of the issues that live in the different communities. So I think the call is clearly there that we need follow-up meetings as this, and also that the upcoming EFGS should have way more EO people than in the past one, and also all our activities at UNEC on ingest, on integration, geospatial and statistical data need much more, both communities working together, and then we will get there, I'm sure. Thank you.
Thank you so much.
Yeah, so thanks a lot to the organization for all of this from ESA.
And the very final words, yeah, Monica, if you could say something on behalf of, because there were a lot of Earth observation companies in the room, so she can say also a few words on their behalf.
Yeah, also being the last one, maybe I go to the very first of here, because I remember 1 year ago when I attended an event from the European Forum for Geographic Statistics. I met to many people of you here, but specifically I discussed with Mark saying we need to do something together with this community, and this is where the stakeholders engagement is coming from. So joining forces, I think we could do a great job, and I think together obviously with the ISA stakeholders engagement and with all these entities, we could bring more communities together, specifically the users. So for me, stakeholders engagement is something that we need to take into account, not for a project, but really as a meaning of collaboration. And I think this is one of the messages here that I think all together we build things. We see all these posters and now we need to build on those. But basically, I think this is now to bring all together here, and I think being the last one, I don't want to lose. But for me, it's keeping the momentum, as I said before. So thank you. We come to the beginning, but in a very different way, because we go from here to here now. So we need to move forward. Thank you.
So we're almost there. I still need to say a few things. I mean, all the presentations, the session summaries, the final report will be put on the website, so you will be contacted, of course, if you want to make any changes to the... Of course, I lost my file. It's a pity, because I have to thank a lot of people. Yeah, I cannot get it anymore. So you will all get... you will all be communicated. So, but I need to thank, of course, the organizing committee, because they play a tremendous role in this conference. I need to thank the scientific committee, the participants, of course, because without you, there's no way that a conference like this can be a success. I would like to thank also the technicians and Jacopo and his team. They've done a really great job. I need to thank, I don't know if there is anybody from the early services, but there was all the ones taking care of the statistic. Ula, you see her with the curly hair here, so she was so important there. The guards, the security guards, I think they are really, really essential to be there. I hope that I haven't forgotten anybody, but there is one person I think that really deserves a round of applause, is Federica, because she did a tremendous work. And Federica, there is a small present for you from all of us. And with this, I think we can close the conference, and thanks to all of you, and really, I wish you a safe trip back home.
My wife is coming to Rome now, and we will spend the weekend. Do you have any recommendation for a restaurant or something?
In Rome?
Yeah.
Sorry.